Hello and welcome to the AWS Community Days Special Edition 2020, the Machine Learning Day. My name is Mike Chambers and I'm an AWS Machine Learning Hero.
And I'm Gus, the head of AI and ML at Castles and also an AWS Machine Learning Hero. And I'm very excited to have you all here today. And to make sure that the smoothness of this event, all of the talks are going to be generated in real time by AI. Sorry, I was just joking. The talk's going to be it's already pre-recorded, and you're going to be watching an offline talk. And however, the speaker will be available throughout the talk to answer your question in the Twitch channel, and while the videos are playing. And we're going to bring them back live after the talk to answer your question right here. Yeah. So please drop in your question on Twitch and just have a fun discussion is fine as well over there. However, just make sure that you follow our simple code of conduct. Yeah? Be polite and kind to others, and share mutual respect with us on promoting diversity and inclusion.
Thank you very much, Chris. So we are streaming live on Twitch. We're also on YouTube. We're also on Facebook. We're at all of the places. So please reach out to everybody you know to make sure that they're watching this event. We're going to smash it out of the park today compared to the rest of the week. A little bit of rivalry going on. So this week, so far in Community Week, we've had on Monday, we had a data day where they talked about all things to do with data and big data. On Tuesday, we had an Alexa and Connect day. So that's all to do with the voice, of course. And yesterday, we had a fantastic day about IoT. And the one thing that I noticed was sort of been a common theme throughout the week so far, and no doubt will be continuing to tomorrow as well, is that everybody talks about machine learning. So machine learning is where it's at. Machine learning is the main topic of the moment. And today, we're going to be focused purely on everything and anything to do with machine learning. So we have in the background producer John. So we're very much indebted to him for his help today. And John, maybe you could throw the agenda up so that we can talk about what it is that we've got coming up today. Cool. So the first out of the ranks, the first off the blocks, if you like, is going to be Gus, and looking forward to this presentation. So you've already met Gus. He's going to be talking about building a bot. This is actually a physical bot to play with his kids. That's amazing. So using machine learning to be able to create models for basically human interaction. Looking forward to that one. What's next, Gus?
Oh, okay. The next one is also equally interesting. It's from Daniel Bradby. And he's going to be showing us how he built an AI on the edge, running on the edge, that actually can coach cricket sports. That looks very, very interesting. Yeah, I'm not really a sports player, but I can see how difficult it is to build something like that. And
yeah,
very keen to look for it.
I'm waiting for you to bring up the fact that Queensland didn't win State of Origin last night, but let's push that to the side. After that presentation, we've got Katerina and Brad. They're from ThoughtWorks, and they're going to be talking to us about machine learning and how it's applied within the resources industry. And
there'll be a bit of surprise. Jeff Barr is going to make an appearance in a pre-recorded video, just to clarify. And who doesn't know Jeff Barr? He's a chief evangelist and a VP of AWS.
So looking forward to that.
Yeah, and followed by another special speaker here. It's our very own Mike Chambers going to be presenting ML plus Lego. What else do you need? ML plus Lego, right?
Nothing. Maybe a cup of tea. That is kind of my thing. But yeah, Lego and machine learning together in one place. It's my idea of heaven. Then we've got Ibstim, who's going to be looking at emotion detection and sentiment analysis in videos. We're not just looking at text, we're actually looking at video. It's a great demonstration. Very much looking forward to that.
And followed by an interesting talk from Prati. She's going to talk about don't dip a toe, but dive right into ML. That's a very good advice. And I totally share this philosophy and
Absolutely.
Looking forward for the session as well.
And Prati actually recently qualified to go through to the Deep Racer event at reInvent coming up later on this year. So it'd be great to talk to her about that. After that, we've got Vivek. We're going to be looking at COVID-19. So obviously COVID-19, big issue at the moment, lots of data around that. So we're going to be looking at how we can use machine learning to look at the sentiment of the discussion around COVID-19.
Yep. And the next speaker will be David Rady. And he's going to be talking about who's that recognition in practice. It's an interesting talk. It's a combination of a mobile technology with the AI. So using AI to help to identify individuals in the senior home. Yeah. it's a very noble cause, and very keen to see this talk as well.
Absolutely. Yeah. And then last up, we've got Olalekem, who's going to be talking about AutoML. And AutoML is one of the newer services that was released, I guess, this year inside of SageMaker, Amazon SageMaker. And so he's going to be looking at how you can actually provide continuous delivery in that space. So really a practical approach to a cool piece of technology. So that's coming up at the end. And then I guess we'll just have a wrap up and we'll talk about the day. Maybe see if we've got any lessons learned.
Yeah. Wow.
There's lots coming up.
That's a lot of interesting speaker, Mike. Yeah.
Yep.
Really looking forward to it. And
so we'll kick off very soon. But first of all, I mean, you're going to be looking at myself and Gus throughout the day. That's we're going to be here guiding you through this journey. We're going to be inside of the chat in Twitch as well. So if you've got questions for us, if you've got questions for the presenters, as they're live and also after their presentation, then head to the Twitch chat section. If you're not there already, then Twitch TV/AWS. You can enter in your questions there. We'll be answering throughout the day, and also we'll be sort of mentioning the ones. If the presenters sort of latch on to a topic of conversation in there, then we'll have a conversation about it live in this room as well. So very much an interactive session. Yes, we can't see you face to face necessarily, but you're absolutely part of today. This is all about community, and you are the community. So great to have you with us. Cool. So there's been lots of things happening, Gus, this year in terms of machine learning. I guess it's been a big topic for a while for us, I would guess. But for everybody now, in terms of the democratization, if you like, of machine learning, it's really happening. And I think for me, it kicked off in a big way, reInvent last year. What are your thoughts?
Yes, I'm definitely with you, Mike. With the introduction of Amazon SageMaker Studio and with the AutoML, those two are really blow my mind in the past in the last year's reInvent. And this is actually the really good start. Yeah, I know they're still early, but it's going to have a very bright future. And I always believe that if you're building an AI ML, it is very hard to build one. You're doing it the wrong way, because the reason why you want to build using AI and ML is because you want the AI to do the hard part, right? Yeah. You're not that capable to do this complicated task. AI is supposed to be the one to do this. So this is definitely the right direction. With the SageMaker Studio and AutoML, you simply pass in your data sets and it will build a model for you, right? So
absolutely. So one of the things I really like about AutoML is that not only does it build the model for you, but it actually builds a set of SageMaker notebooks to sort of show what it's done. So it's not like a complete black box. And in many ways, it sort of helps you understand the process and shows you techniques that you might want to try yourself. So AutoML's got like lots of different avenues to it. It's not just producing the model.
Yeah, that's actually quite true, Mike. And with this as well, you can use it as a tool to actually learn. So you can actually learn all of this variation of notebook that using different kind of algorithm to try to build multiple models. So from there, then you can actually expand the model further if you want to, or you just basically read this notebook with each one of them have actually thorough comment for you to read why they're doing these certain steps. So for me myself, it's very, very useful for me to learn those areas of technique that they use there.
Absolutely. So that machine learning and us learning as well. And anybody who knows me knows that I'm super keen on that. And I also mentioned there Jupyter Notebooks. If that is something that you haven't come across yet, then that's totally fine. You absolutely need to reach out and we can talk about it more, because you need to know about Jupyter Notebooks. But we talked there about AutoML, and obviously we throw a data set in and largely it sort of works to try and figure out what's the best thing to do with that data. The other thing which I think has been really interesting for a little while now, but certainly as it's progressed this year, has been the AI services from AWS. So to be clear, AWS basically talk about their machine learning service stack, if you like, in 3 different layers. You've got the AI services at the top there, which essentially are API-driven services. They are basically black boxes. You throw data in and they do amazing things. Then you've got the sort of mid-level, which is your SageMaker level. And then we've got that bottom level, which is sort of the raw infrastructure, where if you really know what you're doing and you really need very bespoke workloads, you can work down there. And Jeff will talk more about this later on today as well. But the thing at the top, this AI layer at the top, really intrigues me. And we've seen some pretty cool innovation in that space this year as well.
Yeah, and for example, the custom label, yeah, for the recognition. And initially, that top layer was designed to be black box, like you said, and there is not much you can customize it with. Yeah, so practically just use it as it is. If you want it to be slightly different, you want to customize it toward your data set, you can. You just have to go down to the lower layer. But AWS is doing an amazing things recently. They start actually expanding that layers down to have a little bit of overlap with the layer underneath. So now you can actually use recognition to actually train your own data sets. This is what they call custom label. Yeah. So
yes,
so
absolutely.
you do not need to manage the service. Yeah. As if you use the lower layers. Yeah, you have to actually maintain the service deployed in your instance of your SageMaker. You have to manage the endpoint. You do not need to do any of this because it's just a top layer AI. That's actually what it's actually designed for. Yeah. But now you can customize it. So this is definitely a win-win for everyone. Yeah?
Absolutely. Look, I'm going to admit to you, and I've said this before, when those services first came out, and particularly recognition, actually, so it was quite a number of years ago that it first came out, I kind of dismissed it as a bit of a toy. It's a bit of a demo. It's like you can go into the actual console, you can click a button, you can see a picture of Jeff Bezos, and it will tell you that it is. Okay, I don't have a practical application for that. But actually, it's really powerful. And now that you've got custom labels as well, you can actually train on your own data set. You're basically, through a very simple API call, you are getting the benefit of not just the compute power, but also the knowledge of those engineers who are working with AWS and no doubt Amazon.com as well behind the scenes to build these machine learning models. And yeah, it goes back to that undifferentiated heavy lifting argument that AWS make. But me clicking a button and uploading a data set there and getting all them to do it usually has better results than me doing it. I'm going to be honest with you. So yeah.
Yes, that's definitely right, Mike. I'm on the same boat as you. So I think we're gonna go back offline for a moment, and then we're gonna prep for the next.
Well, I hear what you're saying there, but just give me one moment, because there is one more thing that I want to talk about. Now, we haven't had a lot of time to talk about this in much detail, but I was thinking recently about what I'm interested in sort of getting out of reInvent and announcements that are going to come up. And for me, I was thinking about, well, I would like to see something on the data ingestion side, something where, yeah, there's a lot of time and effort and focus spent on things like AutoML, for example, which is automatically generating your model. I'm interested in how can we automatically cleanse data sets and prepare data sets for machine learning. And I was thinking, I'm gonna mention this tomorrow, because I was literally thinking about it yesterday. I'm gonna mention this tomorrow. And then I wake up this morning to a blog article for a product called Data Brew. I don't know a lot about it because I haven't had enough opportunity to actually look at this, but it sounds as though AWS is actually doing this. Maybe they bugged my brain and they can literally hear what I want.
They're reading your mind. Yeah.
Yeah.
You have lots of AWS toys there, right?
Yeah, I have. And I need to mute my Alexa more often to make sure that I'm not being spied on. But no, so we have this tool set now which sort of fits in with Glue, which allows you to look for, you know, I guess it's again, if you're looking and you're watching now, you have the benefit of being able to go to the AWS News blog and read this. I've only managed to see some part of it, but it's essentially allowing you to manipulate your data and massage your data and prepare it for things like machine learning through a GUI tool. So it's an environment to help you do that. I do think that's pretty exciting. So it's cool to see the direction that we're going. But talking about the direction that we're going, I think it's time for us to go to the agenda slide, and we'll come back to you. Oh no, we're not going to agenda slide. See, it was all going so well. We're going to jump into the first talk, and we all know who that first talk is going to be. It's going to be Gus, who's going to who is online with us now. But it's your presentation, Gus. I'm looking forward to seeing this. So you essentially are creating machine learning models to put onto physical devices to help your child, which I think is an awesome and noble thing to do.
And help myself and my wife too.
Yeah, spare time. So, so producer John, could we go to Gus's video?
Hi guys, my name is Agustinus Nalawan, and I'm the head of AI and ML at Castles.com. And today, I'm going to tell you a story about how I built Curio. It's a bot that can play a YouTube video for my toddler. And when I tell people about this project, most of them react the same way. Ask me, why do I build this bot? And it's because of Taxi. He's our 2-year-old toddler. He's a very curious boy, and he likes to point at things like this whale in his favorite map book and ask me to explain what it is. And when we travel, he pointed at this aeroplane wing and asked me what it is. And so does this photo of a delicious bowl of ramen. During COVID-19, our state Victoria in Australia got hit the hardest. All of the restaurant, entertainment venue, schools, and childcare are all closed. And Dexy is not big enough to go to school yet. However, given that both of us working full-time from home, sometimes it's very hard to always try to keep him a company. So I need something to distract him whenever we're busy. And the second is the STEM. I'm a big believer that in the future, STEM is very critical. So I want to expose Dexy to it as early as possible. And with these two reasons, I come up with this concept. I want to build a bot, and it's a very cute one, which can interact with Dexy. It can greet him, hi Dexy, and it knows he's carrying a panda. Yeah? And I say, hey, it's a panda. And it will search and play a video about panda on TV for him. Yeah? This is a self-serve entertainment tools that I need for Dexy. And I decided to name him Curio, which stands for question and curiosity, which is the Dexy's characteristic that he demonstrated earlier. Curio consists of several components. Yeah? A coordinator, which coordinates everything. It has a visual presence, yeah, to animate the Curios, yeah, avatar as a dog, yeah, and a side component which connected to the camera, constantly detecting the presence of a face and a toys, yeah, and a speech to be able for Curio to talk to Dexy, and finally a video playback, which let Curio to look for a video about panda, train, whatever it is, and play the video on TV. Yeah. To be able to run all of these modules, yeah, we need a hardware platform. Yeah. And the perfect hardware platform that I found for this project is an NVIDIA Jetson Nano. Yeah. It is a microcomputer that runs Ubuntu operating system and is GPU enabled, and it has camera interface with audio and video connection, so you can play something on TV, yeah. And it has internet connection, yeah. And finally, it's super cheap, only $59 US. Yeah, it's a perfect device for this. A Jetson Nano is a fully can run full operating Ubuntu operating system, as I said earlier. Yeah, if you connect a keyboard and mouse into Jetson Nano, this become a fully working computer. Yeah, you can run your IDE right inside this. Yeah, so you can debug and test your software very easily. Yeah. In the next few sections, yeah, I'm gonna take you through the journey how I built various component one by one, starting with the visual presence, yeah, which is the most important modules for Curio. Why? Because we're dealing with a tough user here. Yeah. In the past 25 years of my experience building apps and services for consumer, this is the toughest user that I have to be dealing with. He has a very short attention span, and he's very critical and unforgiving. And he will give you zero feedback. If he does not like what it sees or hears, that's it, walk away. Zero feedback, zero rating. So, guys, I'll introduce you 2-year-old toddler. In order to win them, you have to create a successful bonding, to get them interested first, so to be able to actually invest and interact more. And what successful bonding means in the area of visual presence, it has to be cute and realistic. And for cuteness, I decided to use Dexy's favorite animal, a dog. And to make it even better, I modeled it after our little dog Pepsi. And my past experience as a special effect and games developer teach me that the most important factor in realism is an eye contact. When two individuals are having conversation, we look at each other in the eye. And if you don't, you will feel that something really off. For that, Curio need to be able to look at Dexy in the eye or me in the eye, whoever actually using the system, right? And for this, we need a head tracking system. The second factor is a fidgeting. Yeah, this is also critical. If you interact with a dog, you will expect the dog to react and behave the same way as normal dog. They wag their tail, they move their eyes side to side and head as well, right? And they flap their ears. Well, the dog on the bottom left corner here is a bit exaggerated, yeah, but you see my point. Yeah? So to hit all of those two factors, yeah, we need a game engine, yeah? And with the support of skeleton animation system, which is just an ability for us to assemble this bot from body parts, yeah? From the head, from tail, eyes, and the body. Yeah? And you can assemble these body parts hierarchically. Yeah? So I can attach the head to the body around the joint, the red dot there, yeah? And I can attach the tail on the body, on the joint, yeah? And so does the right and left ears, and also the eyeball and the eyebrow, yeah? And with this attachment, now, I can actually perform a local transformation. And what it really means is, I can move these ears around its joint where it attached to the head. And I also can move the head around its joint on the body, yeah, like this. I call it apparent transformation. Why? Because if you notice, by moving the head, I also move all of the body parts that attach to the head automatically, yeah, which is the ears and the eyeball and eyebrow. Yeah? This is what parent transformation is called. So, for implementing this, I'm using the Arcade Game Engine. It's a framework available for Python. Yeah? It's OpenGL accelerated, which is awesome because we can run this inside Jetson Nano with this has a GPU. It means the animation is going to be very fast. Yeah? And it supports sprite transformation, so you can move, rotate, translate, and scale all of these body parts independently. Yeah, which is exactly what we need. However, it does not support skeleton animation system. Yeah, so you cannot really attach a body parts into another body parts, yeah, hierarchically, just like what I described earlier. Well, it's not really a big of deal, yeah, because to build one is not really that hard. Yeah? If you still remember your junior high school mathematics, the matrices, yeah, this is where exactly matrix is being used for. Yeah? You can represent a translation, rotation, and a scale, yeah, using a matrix transformation. Yeah? So each one of them has their own matrix representation. And you just simply multiply your x and y point with the right matrix, you'll get the transformation that you want. Yeah? So it's not really hard. And to be able to animate an object, yeah, you need a keyframe animation system. Again, this is just a jargon for a transformation that's applied over time period. Yeah? So, for example, if you want to do the side-to-side eye movement, yeah, you just simply need to do a translation of the eyes from left to right slowly over time. Yeah, and if you play it over time, it just become like you get the animation that you want. It's nothing complicated. So after building all of that, here is the end result. Yeah? You can see the curio is wagging tail, flipping ears, and moving the eyes randomly. Yeah? So the visual presence module is done. Next is the side. Side module, the guts of it is an object detection AI model. Yeah, this AI model need to be connected into a camera feed. Yeah, and for the camera, I use this Sony IMX219. It's awesome camera, only $25. Yeah, but it delivers exactly what I need. Yeah, and this object detection model is responsible to find the presence of a face and a toys. So building object detection AI model is actually not hard because there are plenty of open source architecture that you can choose. Yeah, SSD, ResNet 50, fast RCNN. Each of them has their own pro and con. Yeah, you got to be careful to choose the one that's suitable with your requirement. Yeah, some of them may be a lot more accurate than the rest with the deeper architectures. However, they might be slower. Yeah, because you're gonna run it on Jetson Nano. It's not like a fully working computer, right? So for the object detection model, I decided to go ahead with the SSD Lite Mobile Net V2, yeah, which meet all of the criteria that I need. Yeah, the accuracy is above 85%, and it can run at least 10 frames per second. Yeah, I do not want it any slower than this, because the slower the object detection model runs, the less frequently it will catch the presence of the face and the toy, and also will slow down the animation, so animation become very jerky. Yeah? So here you go. To train the object detection model, yeah, I split my datasets into 4 classes. So I want Curio to be able to detect face, and also 3 of Dexy's favorite toys: panda, aeroplane, and train. Yeah? And for each classes, I have 150 images. Yeah? And the resolution of the image is not high. It's just 300 by 300 pixels. Yeah? It's pretty good enough. Yeah? So the next step for me to do is to actually label the datasets, which is really annoying. Yeah, it's very painful process. Yeah, because I have about around 150 by 4, right? Yeah, so it's about 600 images to label. Yeah, I'm using labeling tools, open source, called EVA, which is quite handy. I can just import a video, and I can actually go to the frame that I want to label the object, and it spits out images with the bounding boxes. Yeah, it's awesome tools. However, after spending like a lot of time labeling a lot of those toys, I want to get some help a little bit in labeling the face. So instead of doing it manually, I use Amazon recognition. Yeah, I pass in those images that come out of the EVA. Yeah, and I pass it to recognition to detect the presence of human face. So for you who do not know, Amazon recognition is off-the-shelf AI service that can return you the most common objects if you pass in a photo. Yeah? Luckily, face is one of them. Yeah? So here you go. I have my face automatically labeled. Once I have the datasets ready, building the model itself is not really hard. And I'm using an Amazon SageMaker Studio here. Yeah? It's a Jupyter Notebook on steroid. With Amazon SageMaker Studio, you can actually launch multiple Jupyter Notebook instances. Yeah? So you can actually conduct multiple experiments and compare the result easily. As you can see here, one of my Jupyter Notebook, yeah, showing my training code for the object detection. And after the training code is ready, I can easily switch the instance from CPU into GPU, so I can actually train a lot quicker, yeah, by simply clicking select instance and change the GPU instance that I need. And because it is fully working IDE, it has a Project Explorer on the left-hand side. So you can also see images very easily, yeah, without the need for you to download these images and then view it locally in your computer, right? And even better, it has a Git integration, so you can version control your Jupyter Notebook. So with that, I launched the Kickstarter training, and when my model ready, here is the evaluation metrics, which looks quite good, MAP of 0.8, and the losses converging down. The sight and the visual presence modules are now completed, which makes it possible for me to build a head tracking system to make sure that Curio's eyeball are following the direction of the detected face and head. And next I'm going to play you a video about the calibration and the testing of the system. Okay, so the next module to build is speech, so that Curio can talk to Dexy. And as you all probably already aware, it is really just a text-to-speech module that drives this. A text goes in, and the text-to-speech spits out an audio for us to play. And for this, initially I was using PyTTSX3. It's an offline text-to-speech framework for Python. It's all okay, yeah, except that the speech driver for Ubuntu operating system is horrible. The audio quality is totally unacceptable. Well, I'll let you to be the judge for this. I'm going to play the audio and you listen to yourself.
Hello Dexy, my name is Curio. What do you want to show me today?
Yep, it sounds exactly like Stephen Hawking's wheelchair. All right, no offense to the guy. I'm actually a fan of Stephen Hawking, but this is definitely no. Yeah? So all of the hard effort that we've been talking about in the past 15 minutes trying to create successful bonding is going to collapse just exactly like this building here. And Dexy will eventually say, no, I'm just going to walk away, and that's it. That's the end of this project. My quest in finding text-to-speech technology next landed me at Amazon Poly. It's an online-based text-to-speech technology where you pass in the text via an API call to the internet, and then it will generate the audio for you to download and play. And the audio result is way much better. And again, I will let you be the judge.
Hi Dexy, how are you today?
I want this voice for Curio. As I said earlier, it's an online text-to-speech technology, and my initial concern was the latency. From the moment I send the text and until I get back the voice. If it is too long, it's going to create a lag in the interaction between Dexy and Curio. However, I was proven to be wrong. The latency is only 200 milliseconds. This is super awesome. I totally can live with this. And as you can hear yourself, the audio quality is way better. And it is cheap. I know that it's actually paid per API call. However, I just need to create a variation of 30 to 40 sentences. So I do not need to recreate the sentence I created earlier. I just simply need to cache them. So with this, the speech component is done. And finally, for the video search and playback modules, I use Selenium automation frameworks that normally being used for QA to test functionality of the web page, to automatically search for relevant video on YouTube Video Kits and play it full screen. And with all the modules are completed, now I set up the Curio system in the living room exactly when Dexy is taking a nap, because I want to capture the first moment Dexy actually see Curio and play with it for the first time. And as you can see in the next video, with some bloopers right at the end.
Do you want to come and play? Hey, I think that is a panda. Hang on a second. Let me play you a video about a panda.
What years is this grade? Let's find somewhere to have.
See, do you want to come and play? Do you want to bring me something? Hey, I think that is an aeroplane. Hang on a second. Let me play you a video about an aeroplane.
Hey! It's me, Uppy! Whoa! And look at what it is! Whoa! It's an airplane!
I think that is an aeroplane. Hang on a second.
No. Yay! It's a successful bonding. And now I'd like to show you a little bit about Curio highlight post the deployment. Curio was showcased in a GTC NVIDIA October 2020 keynote by Jensen Huang. So I was quite excited and surprised to see it. And it was also awarded as a project of the month for Jetson Nano by NVIDIA. And finally, thanks to you all audience for listening and watching. And if you want to know more about me, you want to know more about this project, go and read my blog and also my other project as well in Medium. And if you want to get access to the source code for Curio, it's all available in GitHub. The link is provided there as well.
I absolutely love it. Gus, that was amazing. I can totally empathize with your use case in that presentation. Amazing. Look, so some questions have come in on Twitch. I have some I want to ask as well. I mean, what's next for Curio? Are the parts that you want to sort of improve? How do you plan to go about that?
Yeah, so one area of improvement definitely is the camera angle. So after Dexy play with it for a while, I noticed actually there are a few blind spots. So if Dexy is standing very close to the TV, right, the camera cannot see him. And also when he's sitting down, yeah, there is a vertical blind spot. He put a toy on the floor, he won't be able to see. So at the moment, I'm using the 77-degree camera angle. So I think I need to use a slightly bit wider one, like there is a 120-degree angle one of the same camera brand. Yeah, so that's something I want to give it a go, and also to improving the hardware as well. So at the moment, the system running about 7 to 8 frames per second because of it needs to do all other heavy lifting, not just the object detection. So using more powerful hardware like a Savior, maybe, yeah, that will be one way to go. Yeah.
Yeah.
So.
Okay. So if you were to change the camera and to change the sort of it makes it a bit more like a fisheye lens kind of thing, would you have to retrain the model on that data?
I know you're going to ask that question. Yes. Most likely, yes, because the augmentation that I perform at the moment, augmentation is like the way you manipulate the image to enlarge your data sets by resizing it, rotating it, and that's not enough because a fisheye lens actually distortion is like a perspective distortion. Yeah. So you've got to actually do a bit of a special augmentation for that. Or you do not augmentation, but basically just simply recording from the same fisheye lens. And that will be your training sets, really. Yeah. So yeah, I have to go through all of that. The headache of labeling this data sets again.
the utter joy of training the data set again. Yes. Awesome. What about voice recognition? I mean, at the moment, like it's being triggered from anybody, I presume. Can it do voice recognition, or could it?
You know what? You're asking the right question, Mike. Initially, that was in the scope. I was actually thinking about having voice recognition to actually recognize his voice. Yeah. But then I just realized after a while, after thinking through it, this is 2 years old we're talking about. Yeah. It's really hard to understand what he's saying just as a human, right? So that's going to be very, very hard for the voice recognition tech to be able to understand what he's saying. Yeah. So then I decided, okay, maybe I will add this module when he's slightly bit older, like 3-4 years old. And then that's the time to introduce these modules. Yeah.
Sure. For sure. Okay, cool. And what about capabilities other than just YouTube? I mean, like other services maybe that it could integrate into.
Yep, that is actually something that I have in mind as well. So instead of just playing YouTube video, I want this to be able to also give him a bit of education. So have an education purpose. So maybe from the toy that he collected, that the Curio sees. Maybe it can actually turn it into a game, asking him back, "Hey, what is this?" Yeah, and then to give him multiple choice question. Nice. Is this a panda? Is it a plane? Yeah. So to give him a bit of like a meaning of with his activities. Yeah. So yeah, so that's one way. Yeah. And maybe even in the future, maybe even can ask him questions verbally. Yeah, and recognize the answer directly from the voice.
That'd be awesome. You can see a lot of possibilities for this, and it could get quite interesting. You know, something that I would quite like to see is the addition of robotics, of course, where you can actually move it around as well and follow Dexy. Not in a bad way, but like, but to have a play friend that follows you around.
that'll be very cool. Yeah, and that's going to be a very long-term project, but. Definitely.
Everybody just needs to see the look that I just had from producer John then. It was amazing. That was great. So, what? But yeah, that'd be excellent. No, it's a really cool project. And look, congratulations. Lots of positive comments about it in the Twitch chat as well, I noticed.
Oh, yeah. Thanks, John, for dropping the GitHub link. Yeah.
Absolutely. So no, that's very cool. So look, that's the kind of thing you're going to have today. You're going to have these kinds of presentations. They're not sales pitches, and they're not they're community projects from community members, just like you watching this. So remember to please let everybody know that you are watching this, and don't let your friends not watch this. So we want to build up those numbers. We want to have a massive following today on this stream, and have the opportunity to have this massive community conversation around machine learning. So yeah, anything more to say, Gus?
I'm actually watching the Twitch comment, actually looking at the question from people, and there is this a question from Prairie. They're asking. I already answered that, but I can actually elaborate a bit further.
Please do, because you know what's happened is that I popped the Twitch chat out and I've lost all of my history, so I can't see anything. I'm sure that someone asked something good.
Yes. So Prati really asks if it is actually incremental improvement, or actually if I thought through all of this module from the start. And like I said, that actually I think through all of this module from the start, except the controller modules, because it's very obvious the component that you need. You need the sight, you need the speech, and you need the visual representation. But one thing that I do not realize, actually, I need separate modules to control all of these components and glue them together. So I was expecting, everything can just talk to each other. There's a logic here to talk to this guy, this speech talk to the vision. But then as I actually go through with this project, the thing's getting more and more complicated. And I just realizing that, okay, you got to isolate this into its own component. Then that's actually hence the controller module comes to life. So it's a product of like an incremental improvement, really, as what Brady said. But
sure.
But really, I learned a lot already from this project, which is good. This is actually always an opportunity for me to learn when I'm building new project. And wow, okay, another question just dropped in there.
Well, maybe really quickly. We're going to have to move on in just a moment. Can't hog all the limelight.
This is a very quick answer, very quick question. How much time do I spend? So roughly about maybe if you condense it into full-time works, about 2 weeks, maybe.
Wow. Nice.
So
thanks for that, Chris. Look, we're gonna have to leave it there. And oh my God, no, come on.
Oh,
it's worth delaying everything for this.
Who
have we here?
So
the star of the show.
Do you want to say hi to everyone? Want to say hi?
Hey, Dexy.
Hi. So I put a lot of barricade on my door, but he's strong enough now to push the door and to get in and interrupt me. So
good on
all
you.
right. So
thank you very much.
Without further ado, let's we'll be back for the next speaker soon.
Thank you. Awesome. Look, it's been it's utter chaos. Never work with, what do they say? Never work with children or robots or animals. But awesome. Thank you so much. Gus, over to you for the next speaker.
Oh, yes, I can hear you.
The
next speaker is Daniel Bradby, and he's from Mental Group, and he's an emerging technology and innovation principal. And the title of his talk is going to be using machine learning on edge devices for sports coaching. And a little bit about Daniel. He brings a software engineering discipline to data science. And Daniel has helped build Eliza's AI/ML consulting business over the past 3 years as its CTO, staying with the Mental Group. Daniel is now the emerging tech innovation principal, charged with bringing interesting and exciting new technology to clients and the broader market. So without further ado, John, let's play the video.
Hi, I wanted today to share my journey exploring using machine learning for sports coaching. And specifically, I wanted to share with you how I've been using edge devices to support that. So devices not in the cloud, but actually devices in the field. The sport I'll be using today is cricket, sport close to my heart, but I really want you to be able to see how this could easily be applied to other sports as well. So firstly, a little bit about me. So I look after emerging tech and innovation at Mantle Group. I've been there over 3 years, and in that 3 years I've been supporting Mantle Group's machine learning business, Eliza, as their CTO. I'm very serious about cricket, as you can see in this photo, holding some equipment that I bought 20 years ago. These days I don't play so much cricket, but support my son with coaching his cricket. So I'm going to cover a fair bit of ground today with the ML approaches I've been using to bring together a coaching sports solution. I'll quickly cover some of the basis of using video for sports analysis and some computer vision techniques as well. But then I'll move into the ML techniques that you're probably really interested in. And these are things like body pose, where the body's moving, shot detection, so how do we know what people are doing in the video shot, and how to bring all that together into a useful coaching tool that we can use actually out in the field. So firstly, a little bit about coaching with video, and particularly within a cricket scenario. So sometimes it's hard in cricket to see or know where your technique needs to be adjusted. The bowling action and the batting action, even fielding, is actually quite fast. And as a coach, being able to see that is quite difficult without slow motion. And even as a player, like, you don't know if you're doing something wrong until you actually see it. So I've been using slow motion video capture for quite a while to show kids how they're bowling and how they're batting and where they might be able to improve. For batting, I want to share with you some of the things we look for here. So we look for a good head position. We look for the head to be nice and straight and level. We want to make sure that the body movement is moving towards the line of the ball as it comes, and that the batter actually makes a good shot selection. By that we mean they choose the right shot to play. Do they play it straight, or do they play it over that way? And they need to do that very, very quickly, depending on which ball has been bowled. And for the bowler, we want to see really consistent bowling. So in the graphic here, you can see a really consistent set of bowling where the bowler has been able to group all the balls within the same spot very, very consistently. They're at the consistent length and they're at a consistent line as well, straight down the wicket. And to do that, we really need to make sure that, again, the bowler's in a good body position when they're moving through that bowling action. And slow motion video analysis is really useful to slow down that and work out what's going on. Is the arm in the right spot? Is the head tilting back? And how we can correct some of those things. So when it comes to taking the next step and I guess automating a lot of that work that I've been doing around analyzing slow motion video, I wanted to dip into a bunch of techniques that we now have access to on these devices to, I guess, help automate that process and bring that together a bit more efficiently. So computer vision on mobile has seen a lot of advances over the last few years. We're getting bigger and bigger GPUs on these mobile devices, and now we're even getting specific machine learning hardware. So on latest iOS devices, Apple devices, you can see neural engines coming into the fold as well. Camera quality is getting higher and higher on these devices. We're getting better resolutions at higher frame rates for our video, meaning we can do better processing on them as well. The machine learning frameworks are finally catching up, and we're getting machine learning frameworks that are targeted specifically for mobile devices that have constrained battery, that have different processing units on them. And not only can we run machine learning models on there, but we can actually do things like train new machine learning models. And we can even manage our models and deploy them and update them on these mobile devices. And all of these things really come together along with some of the existing computer vision APIs that are on these devices to really give us these big experiences. And for me, I really saw this come together at the recent Apple developer event, so WWDC 2020, where they released iOS 14. The picture in this slide here is an app they built to really demonstrate bringing together multiple machine learning techniques on the device to actually run and score a game. So in here they're playing a game of cornhole where you throw a sandbag into a hole, and to score it, it's able to work out if the ball landed in the hole or not, what speed it did, and even how the player actually did that. Did they throw it overarm or did they throw it underarm? And when I saw this being presented and the APIs available, it really triggered in me what opportunity I could use that to bring that to other sports. So I want to build up a couple of these techniques into a complete coaching app and show you how I've done that along the way. And to do that, we're going to start with something called object tracking. So you can see in this video here, there's something moving through the air. It's moving in a nice parabola shape, and we're able to detect that movement through something called frame differentials. So to do that, we take each frame of the video and we look at the difference between each frame. And if there's a difference between each frame, then we can detect that something has moved in that frame. So in this particular scenario here, we can see there's something being thrown at the top, we can see an arm moving, and we can see something along the bottom as well. So we're only interested in that object, that ball or that sandbag that's moving at the top. So then we apply some additional techniques around object filtering to let the APIs know that, look, we're only interested in an object that is no bigger than this and is no smaller than this. And this allows us to filter out things like the arm movement and the shadow, which is the object movement at the bottom of the screen. This is not a machine learning technique, this is a computer vision technique. And by that I mean we're not training a model on data. There's no reason why we couldn't look at using an object detection technique, but this object tracking technique has proved to be quite successful. This is a video that builds on that technique and does something called trajectory estimation. So what we've done here is we're looking for where those objects are moving and trying to build them into a form of a parabola which a ball would fly through. This video shows me bowling, the flight of the ball, and importantly what we're trying to achieve here is where did that ball land. We're even able to detect a second bounce, so a second parabola where it goes from down to back up again, and that point where those two trajectories join is the point where that ball is landing on the pitch. And if you remember back to the earlier slides where I talked about how we want to judge how a player is bowling or batting, these are really good automated techniques for us to do that. Furthermore, once we've detected that trajectory, we can actually store the parabola that created based on the coefficients for a parabola. So the equation for a parabola is ax squared plus bx plus c. We can store a, b, and c in a database and then be able to recreate that on the screens, so we don't have to store kind of the raw data. Next, I used a technique called body pose estimation, and you saw some of this in the previous video. So in this video we can see individual body points, which are the dots being detected as a player is actually moving through a bowling action. And then I've been able to group those into particular segments around their eyes, the hips, shoulders, and legs and arms. And this is really useful to be able to detect a lot of movement issues through a very fast action. So for a bowler, I really look for a steady eye line. You can see at the end of this clip here, the bowler's eye line is actually nice and level, so their head is quite steady as they let go of that ball. We can also look for other things as well, like balance and body weight transfer throughout the bowling motion. We can also use that body pose information with batting as well to determine what shot is being played. So this video here is my son playing a straight drive, and the body pose information is useful to help firstly understand if his technique is correct or not, So in this shot, I'd probably suggest he wants to bend his elbow a little bit more so the ball doesn't go so high. And if his head is over the line of the ball or not. But additionally, what I've been able to do is use that body pose information to determine what shot he's being played. So I can tell this is a straight drive here, but I can actually, and have trained a machine learning model to look at all of that body pose information and translate that into a prediction about what shot is being played. Is it a straight drive, or is it a cut, or is it a hook? All different shots like that. And the way we do this is we capture those body pose information over a series of frames, in this case 45 frames, and each one of those frames, it forms a sequence of body pose movements. And when we train a model and say a straight drive looks like a sequence of body movements like this, then it helps the machine learning model understand that that's a typical movement and shape that you would see if they're playing this particular shot versus another shot. What I want to use this particular technique for is to be able to work out how many times a player plays a certain shot, and if they're playing the right shots for when the ball is landing in those certain spots on that pitch. And I want to do that in a really automated way as well. Now, again, to kind of support the automation of what I'm trying to do here is that I don't want to have to log into the app and register which player I'm working with, because when you're coaching kids playing cricket, there's probably 30 kids running around, and having to work out who's batting at the moment and write the results down against each person is actually quite time consuming. We can use some simple, again, off-the-shelf facial recognition models to actually build player recognition. And this is what I've done. So I've built up a bit of a database of different players in the team, and being able to recognize each one as they come in to start batting or they come in to start bowling. And then when I see them play a shot or bowl in a certain way, I can record that information against the particular player themselves. Now, initially I was a little dubious about whether this would work or not, particularly with the amount of equipment that you wear in the sport. You can see in the shots here that I've actually made sure that we used helmets to see if it detects the right people or not, and it certainly does. What I did find, however, was that there's a point where the resolution of the camera gets so low that the detection starts to not work. So a little bit of a concern here, but in the testing I've done so far, that this actually works quite well. So as we're talking about some of the challenges, I want to lead into, I guess, where I've ended up going with this solution. And I want to highlight some challenges I've found along the way and some of the solutions that I've managed to start putting in place. So firstly, you'll see in this video here that the trees are moving slightly in the background there. Now, that's not great for that first technique we talked about around object tracking, where we track differences in each frame, what has moved in each frame, to detect if there's a particular ball movement or not. So to help support that, we do some filtering, like I mentioned before, around object size. But when those movements are around the same object size that we're looking for, we can use other techniques as well. And so we can use an area of interest. So I can limit the area of interest to the pitch area there to help with that information as well. But sometimes that camera angle is just not perfect for what we need to do. You can see the one I've chosen there is straight down the pitch, right next to the chains, and that's not a great angle for what we need to do. I actually need the angle to be out of the way for a start. So all this was done with a camera on a tripod. What I really want to do is be able to mount these cameras. So if you look at up the top of the cage there, you can actually use a really good spot to be mounting cameras down towards the batter, but also a multiple camera system where I can mount a camera back towards the bowler within the same computing unit. These are all things that I can't do with a mobile phone. And finally, what I saw using the mobile phone as a test bed for this, I guess, was that it generated a lot of power, and outside in the sun it gets very, very hot and won't last very long. And so I guess for me the mobile phone was a good kind of inspiration and prototyping ground, but I really needed to come up with a more permanent solution if I wanted to build this any further. And in fact, I have. So moving towards a bit of a pilot system now as we move into the cricket season. Mobile's been useful, like I said, to inspire the idea and prototype, but we really need to look at a more kind of permanent or semi-permanent solution. So what I've come up with here is using one of these NVIDIA Edge devices. So these devices here are basically an embedded Linux device with a great big GPU on here that's really optimized to run machine learning models. And further than that, these devices are actually very, very good at being connected into cloud environments. So connecting into AWS's IoT Greengrass to be able to manage code on the device, so when I want to update it, and models on the device as well. Because what I'm talking about here is deploying this in a field up high where I can't reach that device all the time, but I want to be able to iterate quite quickly over the length of the pilot over summer. And so building a mechanism where I can now deploy these models onto this device and update them quickly has been really, really useful. Also being able to bring models that I've built in my prototyping stage on the device and use them within this NVIDIA device has been useful for me as well. So I've been able to take the body pose and shot selection models and then move them into Amazon SageMaker. So SageMaker's allowed me to train my models there based on the data I'm collecting, but also to be able to deploy them back out onto the edge devices themselves. And that's been really, really useful. And finally, this particular device here, I've got a single camera on it today, but they support multiple cameras. So I can actually use that single device and point it back across towards the batter and the bowler. So once I've collected all that information on that device itself, using the cloud environment, I'm being able to store the players, I guess, information and statistics about how they're playing back on a back-end database. And this is where I can use the mobile and become quite useful into a coaching app. So I'm building an app that will allow me to see at an aggregated level how well this batter played versus how well this bowler bowled, and then dig into that next level of data if I need to. So I wanted to thank you for listening through that, and I hope it inspires you to try out these sort of solutions for the sport of your choice, and feel free to ask me some questions and I'm happy to answer them. Thanks.
And we are back. And we have Dan here joining us today to answer your question. That was a definitely very interesting talk today, Dan. Yeah. And I've got a question here from the floor. I'm just wondering if you post estimate and predict the ball trajectory in 3D space, because otherwise, if they are in 2D, it means actually it's bounded to the angle where how you train your model with, right? You want to elaborate more about this?
Yeah, definitely. And that's one of the challenges that I kind of talked about at the end then around having multiple cameras and camera positions. So I'm finding having both a front on and a side on view for pose is going to be really important. So, you know, my single camera approach is certainly not one that's going to work beyond this, but with the multi-camera approach I've got with the NVIDIA going now, I'll be able to kind of project into that 3D space a lot more.
Cool. So do we have any question from the floor, Mike?
Yes, we've had a lot of stuff coming in during that presentation. Clearly, quite a lot of cricket fans in the chat. So we have one. Well, we have one here. Just curious if the same ball trajectory tracking is used by the LBW review in international cricket, or I guess anybody else's cricket for that matter. Do you know much about that?
Yeah, I definitely did a bit of a looking around to see what technology they use, if they use computer vision or if they use object tracking. They don't release a lot of information. I guess it's much proprietary behind the scenes, but it definitely inspired what I was trying to achieve. And when I saw that could be achieved with this sort of computer vision technology, yeah, I definitely deployed it that way.
Definitely proprietary technology. Also, you kind of don't want like all of those fans pouring through the source code saying, no, I realize why the player wasn't out.
Yeah, can you imagine that? Yeah, a lot of arguments.
A lot of arguments, yes.
So there is another question here. Do you have a plan to improve your prototype to coach players for other roles like bowler, wicketkeeper, and fielder?
Yeah, that is a good question. Wicketkeeper I hadn't thought of before. Fielding, definitely. So I've been capturing a bunch of catching photos because I've been using slow-mo video analysis for catching techniques as well. So players can kind of watch the ball as it moves into their hand. They're moving nicely towards the ball. So that's definitely on the cards for fielding. Wicketkeeping I hadn't thought, but there's definitely some techniques that I can use for that. And bowling is already on the cards. That's the sort of thing that I'm doing already, definitely.
Cool. Awesome.
Cool. There's a long question here that I want to ask you. It's actually, I think it might actually be more to do with cricket than it is to do with machine learning, but I'll allow it. That's fine. So let's go through it. It says there have been some instances where people have used unconventional techniques, mostly bowling apparently, to some success. I think what they must be talking about coaching techniques maybe through these types of things. How do you ensure that you're not pigeonholing players to certain styles or techniques and perhaps exploring new techniques and new global minima, which would potentially be better than existing conventional knowledge? Is this a case of you're actually using machine learning to then train people into certain ways of playing, maybe?
Yeah, kind of. That's definitely a danger, and it's probably worth calling out that we should be mindful of that when we deploy this sort of technology. So probably it's incumbent on me to make sure that I'm analysing the core principles of what needs to be achieved in cricket, which is, just good head position, good balance, good movement, as opposed to going, oh, you moved too far to the left. We can see some of the best cricketers and bowlers today, they do really strange things and they're the best in the world. So let them keep doing that. But if you look at their core things they're doing, they're the things that I'm trying to coach for, to make sure that when someone's bowling, their head doesn't fall backwards, or when someone's batting, their eye lines on the ball. But it's a good question.
Do you think that this technology could be used to make Gus a cricket player? We were talking about this before. Gus, do you know what LBW stands for?
I'm sorry, Mike. No idea what it is.
I don't know that we have time to go into it now, but that's fine. Gus, go ahead.
Definitely can be used for other sports as well. I guess the thing that struck me about this, and when I talk to other people about it, is that they immediately thought of the sport or the physical work that they do and go, oh, this could be applied there as well. And that's what's really exciting about it. And that's what kind of inspired me down this track as well, is I saw someone using it for this silly game of cornhole with a sandbag. And I'm like, hey, I could use that for cricket. And then I talk to someone else about it and they say, hey, I could use this for fitness training. Like, it's great. It's really inspiring.
Gus, you need to come up with another question before we start talking about state of origin.
Yes. Okay.
I'm not happy about this.
I'm just about to cut the conversation about cricket and back to the MLM, right? There is this ML question from the floor. How important it is to run your model in real time on the edge? And could you get a better performance by running the model asynchronously on the cloud?
Definitely. I could actually shuttle all of the video to server side, and I could likely get better accuracy because I could have bigger models and do post-processing on it, definitely. And that's definitely on the cards. Like, I think in some of the architecture I've got there that shuttling that video back to the server is on the cards. In the particular pilot deployment I'm looking at the moment, it's just not reasonable when I'm talking about like 4 nets and 4 cameras for each one, for each of those video feeds to go back to the server. It's just not feasible at this stage. So that's all.
So maybe like a hybrid model, Daniel. Like you post estimate on the edge, but you send the point movement to the cloud for recognition or something like that.
Yeah,
for classification. Yeah.
And I think it's also useful to go back and have a look at some of that video as well. So, if the ML model at one point says, hey, something bad happened here, the coach probably wants to go and have a look at that and be able to track the video at that point in time. Could be really useful. So maybe a hybrid approach, and maybe thinking about resolutions as well of the video that I shuttle across.
Cool. Thank you.
Sure. Can we talk about hardware for just 1 second? I've been playing around with machine learning for quite some time, and a lot of the stuff that I'm doing is in the cloud. And I don't know about the audience here today. Maybe we're also sort of playing around with SageMaker a lot. And it's actually that bridge over into the physical world is something that I know a lot of people want to get into. What's the learning curve like to be working on, let's call them, embedded devices?
It's a lot simpler than it used to be. it used to be, a lot of embedded devices were really difficult to use, but these sort of, Jetson devices now, they're basically Linux. So, if you're running this stuff on a EC2 instance running Linux, then you can run it on this device as well. Like it's not that difficult. There is different challenges around power and, access and deploying new models and things like that. But really, it's a lot simpler these days. I particularly like that Jetson because of that. There's other devices like the Intel NVIDIA stick here that is a bit more complicated, same as the Coral Edge TPU as well. Like these devices were things that I was considering using, but as soon as it was a more familiar environment on the Jetson, then a lot of those barriers go away.
For sure. And you're using Greengrass, or you're sort of moving towards Greengrass for the deployment. That's right?
Oh yeah, definitely. Like I wouldn't deploy this without being able to iterate on the model or iterate on the code and have that device managed, because as soon as I mount this up somewhere that I can't access it all the time, I know I'm going to want to be able to update this all the time. I'm still in a pilot. And the services like this didn't exist a while ago. So I'm plugging this straight into Greengrass to make sure I can iterate on that model and that code.
For sure.
Yeah, so I think it's still around the similar hardware lane, but slightly into like how the deployment works. I'm actually curious, like, what are the steps for you to bring your model? I believe it is a custom model in Amazon SageMaker, right? All the way down to your device using AWS Greengrass. What are the steps, if you can actually give us a little bit more details?
Yeah, so one of the models that I have is a custom model. It's the one that detects, based on someone's body pose movement, what shot they're playing. That's basically quite a simple neural net, multi-depth neural net. To train that, I have about 100 photos of each different, or 100 sequences of each different shot. And what I'm using in SageMaker is the ability to, I guess, train that in a container. That's been really useful for me because, remember, this is a model that I've prototyped on a different platform, but essentially using the same framework, and being able to bring it over in SageMaker, train it on a container, and then deploy it from that environment, from that S3 bucket through Greengrass has been really, really useful.
Cool, awesome. So
no, go ahead, go ahead.
Yeah, I think we'll be back. Well, thank you for joining us today, Dan, and it's an awesome talk, and we'll be back online soon.
Fantastic start to the day, a couple of great presentations, and we are continuing on with more. So now we have a video from Katerina and Brad. Katerina is a data engineer at ThoughtWorks, experienced in different types of data projects in a variety of different industries, has a passion for IT challenges. Obviously, I'm reading this right. Sweets, and she plays the accordion, apparently, which we absolutely need to talk to her about when we come back after this video. Brad is a senior data scientist at ThoughtWorks, and we're going to have to ask him if he plays the accordion too. So we'll talk to them after their video. John, please roll the tape.
Hi, folks. Thank you for joining us in our session where we're going to talk about evaluation of machine learning applicability for research industry. The journey from the idea of having machine learning solution to the ML product building quite often faces challenges along the way. And sometimes from the very beginning, based on the assumption that machines can solve every business problem and ML solution is the good fit. However, in the real-life scenario, the complexity of the decision serpentine depends on the specific business context and the specific business problem. It requires a thoughtful assessment before starting the implementation and invest time and money in ML product development. And if not machine learning solution, then what's the best alternative to go with? In this session, we'll talk about our journey of the ML evaluation in mining industry, the approach we have taken, and the challenges we have faced. To begin with, heavy industry typically relates to a type of business that carries a high capital cost. And being business-oriented, its products are used by other industries. The challenge we wanted to solve is machine learning appliance in the operation processes of the mining industry. We wanted to find one particular process to improve, try to apply ML, and see what are the advantages it can bring to that process. And as we find out, one of the crucial parts of the mining industry's challenges, being business-oriented industry, is putting prices on its products right. Product premium is one of the pricing examples, is the vital part of the sales process. It's a multidimensional value as it comprises from a lot of input parameters, such as market trends, region, freight cost, production cost, type of material, business customer relationships, and so forth and so on. And the questions we wanted to answer were, how is it possible to help business to set up the correct price? Is there any opportunity for ML to tackle this non-trivial problem? And can the process be automated first as the alternative? And in order to assess the potential solutions, we come up with the following strategy. Firstly, we wanted to validate an ML and automation in a lean way before full implementation through fast experiment prototyping. Secondly, we wanted to gradually transition from business logic, which is basically a set of rules and parameters, to a ML model approach. And thirdly, we wanted to place the user of the model at the center, make it easier for them to use the model as opposite to the model at the center. We also wanted to play back to our users often and have their feedback, even if the solution was in prototype development phase. So here's the architecture we come up with. We put identity and security design at first. So we have established VPC with no internet access. We've got IAM, KMS keys, AWS config. We have provisioned Amazon SageMaker with Terraform for infrastructure reusability and fast setup. And the SageMaker had limited access to the required data in S3. We found this architecture is very quick to develop and extremely efficient for fast prototyping in SageMaker notebooks. And pre-existing SageMaker packages and functionality enabled us to jump into evaluation journey straightforward without operation overhead, like library installation or management of the development environment. So here we go, our first experiment, which was about automation of product premium. And the question we wanted to answer was, is it possible to automate the existing product premium setup? We have been doing our experiments in small iterations. Typically, each iteration took something between 2 or 4 days, and we aimed to have users' feedback after iteration was finished. So iteration 1 of the experiment 1 was about data exploration, as we needed to answer the question, like, what data tells us? Is it complete? And the result of iteration 1 was to go ahead with the data, and we found out that 1 year was enough and clear to build experiment on. So iteration 2 was implementation of just a core product premium range logic. And because usually PP is not just a particular number, is a range, say from $100 to $200. And we based our iteration 2 on 1 year of data and kept logic simple, relied on one parameter only, which was net cash margin, to help to come up with a product premium. After the playback to the end users, the result of iteration 2, we've got useful feedback to build our third iteration on and improve experiment outcome. So iteration 3 was the expansion with additional parameters. We have included market data analysis and started introducing next best alternative product, as sometimes it's more beneficial for the customer to have alternative product with similar parameter rather than initially asked one. So therefore, by gradually improving the outcome, we've been able to capture all business logic through all our iterations, and more importantly, we made sure that we captured it right. So this slide illustrates the result of iteration 2, when we already been able to show something to our users. So this graph shows the relationships between net cash margin and product premium. So salespersons can view what product premium is achievable based on what NCM. So basically what product premium they need to aim for. Now I'm gonna hand over, talk to my colleague Brett to talk more about experiment 2.
Hi. So next, I would like to share another example on what Kate has shared about using lean and rapid experimentation. So in this case, we're talking about building a next best alternative product using machine learning. And the question we want to ask is, how can we validate them in a lean way before we build an actual ML solution? So if you look on the right corner, this is some of the thinking we have in mind. So to build the next best alternative product, we already have certain way to conceptualize the similarity. So we know of some way we can implement the similarity measure by a model. So to get started, we just the first iteration is really simple. We just pick up small sample data for 1 month only, and we just try to implement that logic to as a basis to build out the next best alternative recommendation. So with that, we are able to iterate, gather feedback, and to understand whether that model has worked or not. So once we have kind of satisfied with what we have, we go into the next iteration. We get even more data for a whole year of data, and we extend to more measures. So in that way, because we now have more data, we would understand what the model, whether the model will be successful with a wider range of data. In the last iteration, we really focus on trying to improve the product as a whole. So we are trying our mock-up and visualization. So on the detailed features that will make the model actually useful. So here in this case, if you think about the iterations, the whole goal is really to gradually make the transition from business logic to the actual model. It involved a few steps. So the step number 1 is really about automating the logic. So it's just a way to replicate the current understanding to make sure that we have no gaps with the way business stakeholders actually define the problems. Now, in the next step, we really just focus on doing prototype. So fast prototypes is the best way to allow us to gather feedback. And once we have that solid foundation of understanding the problem and understanding the solution, then we proceed to the final one, which is to build the full ML solution. Now, this is a slightly different way to view it from a product viewpoint. So what we really start quite lean. With just sample data, which allow us to refine and feedback. And then after we try to apply them on a larger scale to automate the entire logic. And then we proceed with building an actual prototype, which is quite similar to the end product, but it's still just a prototype. And in the last phase, when we do the actual full implementation, then we focus more about integration into the current workflow. So why are we doing all of that? Apparently, the whole reason for validation is to make sure that the product we are using will be useful. So it's not, it shouldn't be just about accuracy, but should be actually about usefulness, whether the actual users will find them to be useful in their day-to-day work. It also has to be easy to use. So if you have a machine learning model that is difficult to understand, or difficult to be understood, or people cannot interpret the results easily, we do not think that we have built a successful ML product. We also want to validate the question: if we build it, even though it's very successful and very cool and very accurate, would they use it? And can the users be confident with using the machine learning? I think that's a big assumption we want to validate. And finally, to operationalize the ML product, is there any way to gradually introduce them to replace the incumbent to lower the risk?
Thank you, Brad. So to wrap up, as you have just seen, it's been a long journey. So say serpentine, where sometimes the way wasn't clear and we needed sort of adapt to the road conditions, users' feedbacks. We have found that iterative approach works very well on these evaluations journeys. Firstly, it has an advantage of keeping iterations small, receive feedback faster, and change something quickly along the way within the prototyping. It also makes sure that by iterating, all required parameters and business logic has been gradually captured and not overlooked. Basically, it's building up the result along the way. And as we have started small, with a small amount of data, and tested our experiment in a lean way. And we also have found that lightweight tools helps a lot with quick prototyping. And Jupyter Notebooks in SageMaker we used did a wonderful job in helping us in our evaluation. Thank you all for your kind attention, and we're now ready to answer the questions if you have any.
Thanks for that video, and I'm very happy to say that we have Katerina in session with us now. Hey, Katerina.
Hello, how are you?
Very good, thank you, very good. And look, Brad is trying to make his way back in, a little bit of IT problems there, but trying to make his way back in, and hopefully he'll be able to join us in just a second. Obviously, we have a lot to talk about from the presentation, but also about suites and playing accordions, because that's put out there, so we have to talk about that at some point. But I guess this presentation, this video, this is about process. This is about the journey through like a machine learning project. And that's a really important part for us to focus on, the real world of how we go on that journey through a machine learning project. You talked in the video about proof of concept. You talked about 1 month of data for that proof of concept. Is that always going to work? How do you overcome that when it's just not enough?
Well, yeah, it was 1 year of data. You're exactly right. And
yes,
for
right, yes.
iteration steps, when you're trying to keep your experiment very small, we found out it's like a perfect amount of data. Once you make sure that it's all clear and you are like ready to build your experiment on, that's exactly what's needed. You don't need to go for more just for the sake of experiment and prototyping phase, to keep it short.
Mm-hmm. And I have another question here. It's around the feedback loop. You know that is, when you build a machine learning model, normally you build a feedback loop to train the AI further. Yeah, but often than not, this task actually consists of like 50% of the development cost of the entire ML project. Is there any trick that you can share how to actually leave it out or actually compromise to an extent for version 1 of your release? So whilst you still can actually deploy and proving the business value.
So basically, we found out that, yeah, then getting the feedback, and it's like crucial. And the way we managed that was like we made our users as the center, so make them to feel that they own it, so they're being a part of the process. That's how they feel more engaging into their entire product development state. That would make them aware what product looks like, that make them more comfortable to eventually use it. Otherwise, some of the users, they were more inclined to using existing solutions, especially when the current one is in prototyping state. So for us, make them feel more comfortable, involving them was crucial. And yeah, they were engaging pretty much. And even from engineering point of view, like we need their feedback to make sure we kept logic right.
Yeah.
Because again, in short engagement, it's crucial. You can't get it wrong from the first stage.
And in terms of the continuous training, do you normally deploy your version 1 of your model while still in POC with the continuous training capabilities?
Yes, exactly. Yeah, that's what we're trying to do. Even if it's not like super practical training in terms of like it's not very intensive. Again, we're trying to engage our users as much as possible, especially at this stage, because they're eventually going to say yes and no for the final solution.
Can I ask you about sort of early on in the engagement, when you're talking to your customers right early on, and when that initial connection is being made, how do you find the general understanding out there about what machine learning can actually deliver versus what their expectations are? How is that mismatched? What are the issues there?
Yeah, that's the very good question. That's exactly the challenge we faced initially, because again, general misconception in business world as well, when they think that the machine learning can solve every business problem, but not necessarily. That's what we try to get to our users and to our clients. And based on the complexity of your business problem, based on a particular thing you want to do, you may come up with a better solution as an alternative way. And machine learning may not be the best for you, and it's good because in this case you'll get even better solution, which could be automation or whatever it is. So let us like figure it out for you.
Right, right. So sometimes querying the data will actually provide the answer. You don't necessarily have to go to a full-blown machine learning model.
Yeah, exactly. You don't have to go to the fancy fancy tool like machine learning. Yeah, and invest time and money in something which may not be that valuable for you. If it's just like say fixed formula and stuff, you can go with a tomato solution on any alternative one. That's for sure.
I mean, obviously, we want to do that because that's where our passion lies, and we want to go there too. But yeah, it's important to get that sort of understanding there, that they actually have an expectation about what machine learning can provide. And it's not going to solve the world's problems. If you don't have the data, then I can't tell you the answer.
That's absolutely right.
So, slight off the topic question. Since you play accordion, yeah, and you also work in ML, right? You probably can guess what my question will be, yeah. Have you ever have any thought, an idea? What if I build an AI model that actually can play an accordion or anything that around the area? You want to share any thought on that?
Well, I think I'm enjoying doing it by myself so much. I didn't even question whether like somebody or something can do it for me. No, it's just like the same like when you sing in the shower. Can machine learning sing in the shower? Possibly yes, but I
like
want to
your
do
thoughts.
it by myself.
Okay, so at least you can get an AI accordion player that plays together with you in duet or something.
As the band,
I
I
can
agree.
see
Yep.
where you're going. You want a generative adversarial network to sort of like accompany you in accordion playing. My goodness. Didn't think we'd be going there.
But that's a good answer.
No, before we leave it completely, Katerina, I just if you wanted to highlight one significant lesson learned, one thing that people can take away from this to say, okay, to try and help them make success of these types of projects, what would you focus on?
I would focus on from the beginning. You need to ask yourself a question and make it very clear for the client that machine learning is not a panacea, but by knowing its strong side and applying it thoughtfully, it can bring a lot of value to the project, as well as it can, it may not it may not if you're not put any thought into development of it first. I hope it's making sense.
I think so. And what I'm hearing here is it's planning up front and setting expectations up front. You're not sort of making stuff up as you go along, like or less so at the big theme level.
Yes, exactly. Yes. So
Yeah.
basically, like whether you're going at all for a machine learning solution, it's a thoughtful process. It does require time, prototyping, and iteration before you make sure that's for you.
Sure. Actually, that leads into a different question I've got here about sort of project management in general. Like, does this kind of thing lend itself to one kind of project management style over another? I mean, can you do agile delivery of this type of stuff effectively, or do you really have to have a vision that's set up front?
Yeah, it's a good question. I think it's more about the approach you take in here from project management perspective. If you see that getting straight away to a machine learning solution may not be the option, you may take another approach, which we've done. We've taken iterative approach to make sure that what we're about to build suits our client needs.
So thanks a lot, Katarina. So thanks for joining us today, and and soon we have a special guest. It's actually Jeff Barr himself. As we said earlier, we're gonna play a video from Jeff Barr, and we'll be back shortly.
Thank you so much.
Well, hello, I'm Jeff Barr, VP and Chief Evangelist for AWS, here to talk to you today for just a few minutes about machine learning and AI at AWS. This is a really huge and important field. Done my best to just give you 5 or 10 minutes just to get things going. Well, let's get started. So the mission that we have at AWS, we want to take the rich experience, the expertise we developed after working with tens of thousands of customers, help you and all these customers address all your interesting challenges using this powerful technology. We really want every developer, data scientist, and researcher to have access to it. We really want to simplify machine learning. We want to make it easy for all developers to easily build intelligent applications. Machine learning went from being simply aspirational to mainstream really fast. Not that long ago, it was limited to just the tech companies and hardcore academic researchers. Things really started to change when it entered the mainstream. Compute power and data became more available, and it's suddenly making an impact across every industry: finance, retail, fashion, real estate, healthcare, and lots more. What we see, going from the peripheral to now being a core part of every business and every industry. Now, we think about ML at a really high macro level as having 3 layers in the stack. At the bottom, you see frameworks, interfaces, infrastructure, all for expert ML practitioners. At that frameworks layer, there's 3 frameworks that are in heavy use: TensorFlow, PyTorch, and MXNet. We see TensorFlow as really the largest community today, and we've got a lot of experience and usage there. Our metrics show that about 85% of TensorFlow running in the cloud runs on AWS. Moving up, we've got ML services, we've got AI services. As I look at that top row, those AI services, you've got pre-built models, you've got simplified, really powerful APIs that with really 1 or 2 calls, you can take advantage of massive amounts of training, of investment, of years and years of work by leading folks in the field. We could pick the top left corner. We could pick vision processing with Amazon Rekognition. 1 call, you can detect text, you can detect faces, you can compare faces, identify objects, identify scenes. Each one of these AI services at the top level gives you a massive amount of power hidden and made available to you behind a few really simple, straightforward API calls. In the middle, you've got ML services for when you are ready to start designing, building, training, testing your own models. A lot of what you see at this level focuses on SageMaker. SageMaker gives you an interactive environment to help you do all what I just showed you. Define the models, test them, run them against lots and lots of different types of data, debug, iterate, and then you get to deploy them And then for the longer term, you get to monitor them and make sure that the results that those models delivered at first continue to work well in the face of perhaps slowly trending changes within that data. Now, we really want to help you to get started in the right way. We've got a ton of different training and acceleration programs, all of which are supposed to help you get really started on your journey just as quickly as possible. We've got in-person training. We go both for the technical and the business stakeholders. We've got free online training. We've got certification programs for developers. We can conduct workshops, help you identify the best use cases for your organization. Then we can work with your team, help to build a proof of concept through our ML Solutions Lab. We also have a professional services team. We've got ML partners. We can go end to end. Working with the partners, you can go from building your models to getting all the way into production. We're here to help. Now, in parallel, you need to make sure that you're building the right set of skills for your engineers. One thing I hear from time to time is organizations are maybe a little bit afraid to move ahead. They're not quite sure that they've got the right expertise on staff to be successful. What we've learned over the years, you can't buy your way into talent. There's just not enough. It's going to get really expensive. What seems to work a lot better is focusing on building your internal talent. We've seen that with the right training, the right encouragement, developers can actually obtain the right skills with a really high success rate when they've got some good hands-on training. To help that, we've got a machine learning university. We've used it for over 6 years to train our own engineers on ML. Just last year, we made a ton of this content available for free to you, to our customers. We've seen well over 100,000 developers start their ML journey with this content since then. We also think this is going to help you to attract and to retain the best talent. Other important programs we've brought to market, things like the Deep Racer, the Deep Lens, both designed to get aspiring ML developers to go hands-on with the technology. The Deep Racer, if you don't know, gives developers the opportunity to learn, to build new skills, and to go hands-on with ML using an autonomous race car. It's powered by reinforcement learning, a 3D racing simulator, and there's even a global racing league. We've had a lot of fun with this. We've helped to organize corporate events, help developers get introduced to ML concepts with the Deep Racer, work with customers like Accenture and Morningstar and Liberty Mutual. AWS Deep Lens, a great camera that's commonly used for learning about object detection and doing sentiment analysis. And this, of course, all plugs in, connects with SageMaker. We've also got tons of great training and certification programs. There's online courses at edX and Coursera and Udacity, all great resources for you to tap into. Time is moving ahead pretty quickly, so let's just talk about a few quick customer examples. Vacasa, they used the fraud detector to help detect fraudulent reservations and improve their rental experience. C-SPAN, they're using Amazon Recognition to automatically index video news footage for search. Saves them tons of time, allows them to make that index footage available to their audience very, very quickly. The NHS in the UK, they're testing the use of AI in their contact centers so they can better understand the needs of their callers. Keen, what they're doing, they're using Amazon Personalized to do better email marketing and driving up their CTR, their click-through rate. And then VidMob, they're using both Comprehend and Transcribe to add text analysis to their creative suite. All right, and one more, we've got Intuit. They're using AWS to forecast their key demand metrics and to more accurately meet customer demand. All right, it looks like my time is just about up. Thanks so much for watching. Hope I've given you a few pointers, a few ideas. This does not even count as an introduction to ML or AI, of course, just something to whet your appetite, maybe raise your curiosity level a bit. Thanks for watching. Hope you use this as a great starting point to learn more about ML. Take what you learn, build something awesome, let me know about it, and enjoy the event.
And we are back with Mike Chambers himself here for Q&A. And well, there is a bit of a surprise here. Mike is gonna show us a live demo of this very cool Lego sorting machine.
No. So let's go to the presentation first. Hey, it's all right. It's okay.
Okay. All right.
So we've just seen Jeff talking about the machine learning stack and some interesting stories, use cases that he's observed from his time as chief evangelist for AWS. Yep. So he's an amazing person, amazing presenter, and we thank him very much for giving us a speech for not only today, but we had a bit of a keynote speech yesterday, I think it was. So definitely go check out the YouTube recordings and stuff if you want to go and catch up with that.
Cool. Thanks for the correction, Mike. And here we have Mike presenting as the next speaker. Yeah. And as you all know, Mike Chambers, he's the AWS machine learning hero and a machine learning trainer. And today he's gonna tell us a story about a fully automated Lego sorting machine. And if you want to know more about Mike, there is a QR code there. Do not scan that code. Right? Okay, anyway, Mike was one of the first in the world to get AWS certified. And since then, he has over 250,000 students from all over the world and advancing career and get certified too as well. And as well as having passion for teaching, Mike is an experienced solution architect working around the world with some of the largest companies in the planet and a startup as well. And wow, Mike actually originally from UK, and then he lived in Queensland, Australia with a dog and a cat. Okay, I do not know how you can make them to get along well with each other. But anyway, without further ado,
just roll the tape, roll the tape.
Yes.
Hello, thank you for joining me in this presentation all about machine learning on the most important day of the week for the AWS Australia and New Zealand Community Days 2020, because this is Machine Learning Day, and machine learning inside of AWS is absolutely my favorite subject. I'm an AWS machine learning hero, and my day-to-day is helping people learn about machine learning inside of AWS. So I'm actually creating a course all about the AWS Machine Learning Specialty Certification, and I'll talk to you more about that at the end of this presentation. But the project that I want to show you right now is actually something that I have been creating for some time, and I do detail somewhat inside of the course as well. And the problem that I've got that I'm trying to solve is all about Lego. And it's all about unsorted Lego, because I don't know if you're like me or the household I live in, but we have boxes full of Lego that's all mixed together. And it would be really great if we could sort that Lego into the different types of bricks that we have so that we can easily build stuff. And my dream is that maybe I can build the ultimate Lego sorting machine so that we can just tip all the Lego in the top and it'll sort all the Lego for us down the bottom or out the side, or however it's going to work. That's kind of my dream. Now, I'll acknowledge for you right now that if I was going to build that, it would definitely include some kind of mechanical componentry to that. It'd be like a robot or something that could load stuff and push stuff around. And that's kind of outside the scope of this presentation, so let's just park that for a moment. What we're going to look at is the other two parts to this, which is the vision part and the intelligence part. So we're going to have images of Lego bricks come into this system that we're going to create, and then we want to classify them based on the brick that we can see. So we're going to use machine learning to do that. It's a classic machine vision and image classification kind of problem. So we're going to look at these two components, and we're going to try and build this out of AWS services. Now, out of all of AWS, there is lots of machine learning services going on in there. And I would love time to be able to talk about all of these, but we just don't have time in this slot. Ask questions at the end if you want, and I'll be available throughout the day. We can talk about all of these services that are available. We're going to look at using SageMaker image classification built-in algorithm to do this. It might not necessarily be the best way of doing it, but it's absolutely a way of doing it, and it's an extensible way. It's a way that you can configure it to work just as you want it to work. And so that's what I did. Now, for the project, and really for any machine learning project, you can split it up, broadly speaking, into three different parts. We have to get the data, We have to create a model with the data and an algorithm, and then we perform inference. So in other words, we get lots and lots of images of Lego bricks. Then we train a machine learning model to recognize those images of Lego bricks. And then we ask that model to be able to classify new images that it's never seen before. So that's essentially the sorting machine actually working. And it's at this point that I need to let you in on a little secret. Machine learning is kind of easy. Now, I don't necessarily mean that completely, but actually with a lot of the tools that we have in AWS, it kind of is easy. The thing that's difficult is getting the data, because to make a quality machine learning model, you need to have good quality data. And for a deep learning rooted solution like we're using now with the image classification algorithm, which essentially uses convolutional neural networks under the hood, you tend to need quite a lot of data. So we have to try and find a way of getting lots of pictures of Lego bricks. Now, I could get a camera and get one of the many Lego bricks that I have lying around. This actually isn't a prop. This genuinely was just in front of me. I wasn't planning on showing you. I could get a camera and the bricks, and I could just start to take photographs of bricks by turning them to different angles and having different light sources and things like that. But to take hundreds or maybe even 1,000 images of a Lego bricks kind of take quite a long time. So I did for a while have an automated process, which I had a turntable, and the turntable was computer controlled. It had a camera, which was computer controlled, and I would turn the brick around and photograph it from different angles. That kind of works, but the trouble with that is you still need to be there to take the brick off and put the brick back on. It just doesn't scale to a decent number of bricks. So I had another idea, and that's to use virtual images of Lego bricks. There are open source libraries out there with definitions and models of all of the Lego bricks that have ever been created. So we could use these 3D models with like a rendering software that can render 3D images from those models. And maybe we could use those images to train our machine learning algorithm and create our machine learning model. Now, we could absolutely do that, and I have done that, but I had to go through a few processes and a few steps in order for that to work. And I'll explain what I did now. So you can have a look at this image of a Lego brick here. It's a nice, neatly rendered image of a Lego brick, but it looks so neat and so tidy that we can kind of tell it's not real. And if you can tell it's not real, and I can tell it's not real, then a machine learning algorithm will also be able to pick up on that it's not actually real, or more to the point, that it doesn't look like an actual image of a Lego brick when we take the picture for our Lego brick sorting machine. So let's go through a few steps to make this image look a little bit more real. So the first thing I'm going to do is I'm going to introduce some noise into the image, just some random values into the image, which makes it much more like something which is coming out of a real world camera. If you zoom right into an image of a Lego brick or anything else for that matter, with most cameras, you'll find some noise in that image. So let's put some of that in so that the algorithm thinks that it's dealing with a real image. The next thing we can do, and this might actually be one of the most important steps that we can do, is we can reduce the size of the image. And this does two things. First of all, it kind of generalizes the image quite a lot. And so now actually it's beginning to look like both of these images are the same. The real brick and the rendered brick actually kind of look almost the same, and you might not be able to tell the difference between the two. So we're making great steps towards the machine learning algorithm also not noticing the difference between the two. Now, this also means that when we actually take a photograph of a Lego brick, when we're doing our inference at the end, we also need to reduce the size of that image in order for the classification to work, but that's okay. That's a relatively easy step for us to make. So let's do that. But let's do one more thing and take even more data out, because as the more data that we take out of this image, the less data that the algorithm has to process, and it makes our training job easier. So now we've taken all the color out of the image as well. So instead of having 3 color channels of red, green, and blue, we've now just got one single value for every single pixel inside of this essentially 2D array of values. An image is just a 2D array of values. So we've got a really small amount of data that represents a Lego brick. And ask yourself this question: if you look at this, can you still tell that it's a Lego brick? And I think you can. And so a machine learning algorithm can learn from this too. Now there's one last step that I want to take to adjust the image of this brick, and that's looking at the background of the image. When we're coming to do our classification, when we're taking pictures of bricks, they could be sat on your hand, they could be sat on a tabletop. That tabletop might be made from different surfaces. There might be some shadows cast around as well. So how do we make sure that the machine learning algorithm doesn't get thrown by that? Well, we look at the background, we take the background out, and we replace the background with different backgrounds, maybe of a similar nature to the ones it might see. And then we use a script that we're going to use to basically produce all of these images of Lego bricks. The script is going to rotate the brick around to different angles. The script is going to have the lighting source come from somewhere slightly different. The script is going to have one of these images in the background, and it's going to rotate it every now and again and to different random angles, so that the machine learning algorithm, when it's looking at these images, sort of gets used to the fact that something that's in the background is in the background and you can kind of ignore it. The thing that matters is this brick that's in the middle. Now, it doesn't know it's a brick, but it's the image that's in the middle of the image that it's trying to classify. And so I did that. I created a script, I ran it up on multiple EC2 instances inside of AWS, and put the data in for the 3D models and generated lots of images of fake Lego bricks. And this is a sample of the images that I created. So they're low resolution, they're black and white, they've got random things randomly placed in the background, and the bricks themselves are randomly lit and are at random angles. So this is the data that I collected, and it's time now to move on to the training stage of creating our machine learning model. Now, as I said before, the algorithm that I'm going to use is actually one that's built into SageMaker inside of AWS. So the image classification algorithm is a built-in algorithm that AWS engineers have already taken and optimized to work in the AWS environment. It's built off of a convolutional neural network, and you can see in the documentation they talk at a fair amount of length about how it works. And you can change all of the hyperparameters, and you can give it the data, and you can tell it how much data you've got. You can do all these things. You can even augment some of the imagery as well, so it can expand out, if you like, the data set that you had. And I'll just go over briefly this process that was followed. So I used a set of EC2 instances to generate the images of the Lego bricks. And I did that just with bash scripting and with PovRay. If you've come across this, it's an open source library which makes and renders 3D images on the command line. So I just put together a simple script that I could repeat and iterate over, spitting out all of these images of Lego bricks. I then put all of the brick images into an S3 bucket, and for this particular iteration I generated 31,000 images of Lego bricks. In other versions I've done a lot more than that, and I can talk to you more about that maybe after this presentation is finished. We then took all of the brick images that were inside of this bucket and I passed them into the image classification algorithm inside of SageMaker, and there are some values. If you are familiar with this, and if you're going to try to do something similar to this, the values, or some of the key values that I used, are written just below that icon there. And so it took 3 hours or so to do this training, which actually isn't very long, but I did have, I think there were something like 10 different Lego bricks that we were training on. So it's not a massive data set. And again, I have done a lot more, and I'll tell you about how I did that maybe in the Q&A section after this presentation. And then we take the model that's been generated and we put it into an S3 bucket. And really, look, I said it before, look, machine learning is easy, the data is the hard part. You see the steps that we had to go through to be able to create the data set, to create this model. Creating the model itself Yeah, we had to set some parameters and then we hit go. And the machine learning algorithm does the hard work of generating the model. Now, we might look at the parameters coming out and say, well, it's not accurate enough yet, so we're going to change some parameters and try again. So we're still present, we're still there, we're still operating this process. But the actual hard work of the machine learning algorithm was developed by researchers years and years and years ago. We're just using the tools that are available to us now. So we've got our machine learning model. Now we need to actually make it available so that we can make inference, so that we can take new images, real images of Lego bricks, pass it into the model and get it to predict for us what brick we're looking at. And so we create inside of SageMaker a SageMaker endpoint. This is essentially telling SageMaker, here is my model, put this on a server, manage the infrastructure for me, bring up this service endpoint that I can hit with my image. I can throw my image at this service endpoint and you'll be able to classify it for me. Now, the endpoint on its own is only really something that we can access from within inside of the AWS environment. And because my machine isn't going to be on the inside of the AWS environment, it's going to be at my house, I need some way of exposing this service to the outside world. And for this simulation, we're going to be using mobile phones as the machine. We're going to take images of Lego bricks with mobile phones. So for this, all the mobile phones are also not actually inside AWS. So we need to expose this model out to the outside world. And the way we do this is with this very simple architecture. We have a Lambda function. The Lambda function makes the call to the model for us, and it is triggered in turn by a call coming through the API gateway. So we actually have an API available to the outside world where images can be given to the API gateway. It will pass them to a Lambda function. It will then pass it into the SageMaker model and get it to make its inference. It will then pass the results back through the API gateway and back to the mobile device so that we can get the classification of the Lego brick. And so that's how we expose the model to the outside world. And that's absolutely what I did. So now is the time. If you have a phone with you, a smartphone with you, with a camera, then you can scan this QR code and it'll take you to a website that I've created, which will actually hook up to the service that I've created with this model. Now, it is limited. It can't do very many bricks, but it can do some. So if you've got some basic Lego bricks around, then it's maybe worth a try just having a photograph. Try and frame it size-wise like you can see in this demo here. So not too close, not too far away, and be nice and be gentle, and it might work. If you don't have any Lego bricks, then don't worry. Built into the web page, built into the little app page that we're looking at, there are actually some sample bricks that you can send in. And if you press the sample brick images, it'll send that image into the service and actually really do the service. It could easily have made this and faked it, but honestly, it's real. It sends the image in to the service endpoint and will give you an inference value back. So please give it a go if you'd like, and let me know how it goes. It's not going to work all the time. It's not perfect, but it does work. And in a minute, when I come back to do the Q&A, I'll show you that it actually works in real life right now. But what we've done here is, I think, actually something quite interesting and quite cool. We're actually now making inferences, machine learning inferences, from a model that's been trained on fake data. But we've done it in such a way that it still works. And so it's a way of collecting data en masse without actually necessarily having to go and collect real images of Lego bricks. We've got synthesized data for a real machine learning model. And I think that's really cool. And it's something that I talk about in more detail inside the course that I've put together for the AWS Machine Learning Specialty Certification. So the course goes through from absolute fundamentals. So if you don't actually really know what machine learning is at its core, then we do talk about that, what machine learning is, what the different kinds of machine learning models and algorithms are. We actually get hands-on as well, building our own machine learning environment and then building models and algorithms inside of that environment and really getting to understand how we use machine learning to solve business problems. It's in early access right now, this course, so that means that I'm still making it, and now's a great time to jump in and give your feedback as it's being made so that you can see the lessons made that you actually want to see to be able to, pass this certification, but also get to grips with machine learning as well. So please, come and join me on this course, but also connect with me on LinkedIn. I talk about these kinds of projects and a lot more on that platform, and it's a great place to be able to just have discussions about machine learning in general. Thank you so much for staying with me through this presentation. I'm going to be available right now to answer some of your questions, and let's also have a look at the app working in real life.
Welcome back, everyone. And here's we have Mike with us, the Lego man.
Thank you. I've been here all day, but yes, I am still here.
And who would not love Lego? Yeah, I will be very surprised to hear no from the audience in a Twitch. Yeah, but anyway, Mike is going to show us a very cool.
Absolutely. Like, so at the end of that video, I said I'd do a demo, and I'm going to do a demo. Like, what could possibly go wrong? Nothing. So I built up this app. Essentially, it's just a web page. So if you saw the QR code from the end of the presentation, I think it was there. If you managed to get that in time, then great. If you didn't, then it's app, so app.brickit.io. And if you go there, you'll get, hopefully, on the mobile is what I suggest. And you can have it running on your mobile, and you can use it to scan Lego bricks. Now, it's got a limited data set in there at the moment, but it should work. Let me see if I can show you. Hopefully you can see this on your screen now as well. And what I'm going to do is I'm just going to use the camera on my phone to take a picture of this solitary Lego brick and cross my fingers. So if I take a picture and say use photo, it lowers the resolution, and then it sends it into the algorithm, and it gets it wrong. Did you see that? It's got it wrong. Of course you can see that. Let's try one more time. The problem can be with the lighting in the room. And at the moment, I've got all my lights on so that hopefully you can see me. And that then causes sometimes a problem with the way that the bricks come across. That's not working either. Let's go to these backup bricks. So if you're using this app, hopefully you've had a little bit more success. Let us know. But if you click on this little section down the bottom, and by the way, I just want Gus, you're going to tell me, you saw this working just a moment ago.
Yes, definitely.
That's important. And
it's a demo.
Nodding as well. That's important. Anyway, so it did work. Anyway, down the bottom, we have these extra images. And these are sort of like there. If you don't have Lego bricks to hand, then why not? But if you don't ever need to hand, just click on one of those. It'll send the brick up. And of course, I put these in because we know they work. So you can see here, it's classified the brick there as a 2x4. And if you're into Lego, then the actual Lego code is a 3001. So if you wanted to buy one of those, you could.
Wow.
I don't link this up to a shop. Maybe I should do that. Maybe that should be an earner on the side. Yeah. So anyway, that's it working. It has got some limitations in the way that it's done. It's built exactly as we've just demoed it. I have built better ones, and I'll talk to you more about that in just a second.
That's awesome, Mike. I know that the demo got sometimes strikes, but definitely I saw it in action just like 2 minutes ago. I'm the eyewitness. And Thank you guys can actually download the app yourself and give it a go, right? What's stopping you guys?
Just a URL. There's nothing to don't have to install anything. I don't know if you can still see it.
And don't forget to press the in-app purchase and then donate some money to Mike. so all right. So here
there you go. It worked.
Oh,
awesome, so that's actually a real picture of an actual yellow Lego brick that I had sat just right.
So, Mike, we have a lot of questions from the audience. Wow, okay, the Twitch is on fire now. I'm struggling trying to collect all of these questions. So, the question number one is, can you train on images of different resolution so you do not end up with overfitting the model to just low resolution images?
Okay, yes. So yeah, you could train models on different kinds of sets. I suppose the important thing is to talk about why I lower the resolution of the image. I lower the resolution of the image to reduce the amount of data, so it makes training a bit quicker. It also helps to generalize the model. So generalize the image, and therefore generalize the model. So if you saw what I did there is I was using 3D renders to create Lego bricks. And if you do that, then you create this image that looks kind of fake. And if you can tell it's fake, then the algorithm can probably tell it's fake as well. And one of the best ways to generalize that image is to lower the resolution down, add a little bit of noise, and then the image kind of looks much the same as any other brick. Sorry, as a real brick. Now, the key there is that when you come to inference time, when you're actually trying to classify a new image, and if you can see the demo, or if you saw in the demo, it's actually lowered the resolution of the image that we're using for inference as well. So that's the important thing, is that we are lowering the resolution across the board. So yeah, you could change the resolution of the imagery to train a different model, but that's not really, that's going to expand the model, make it maybe more take a longer time to train. So not necessarily the reason why we did it.
Cool, cool, awesome. Thank you, Mike. And the next question is it possible to train, to add a new Lego brick shapes into the existing model without retraining?
Shapes. Without retraining, no, but with retraining, yes. So at the moment, it's trained on a handful of bricks. And that was largely due to sort of like just iteration time. And I suppose similar to what Katarina was talking in the previous one about just taking a sample data set to start with and sort of working with something and proving that it works. That's kind of what I've done here. And so I've worked with a subset of popular bricks so that we know we've got those. Absolutely, we can expand this out. The ramifications of that will be more training time, bigger model, and the rest of it. But yeah, that's probably where I'd go next. There are some changes though. There are other versions of this that I have since created. It's important to know that this image classification of Lego bricks is basically my standard go-to for machine vision kind of problems in machine learning. So if I'm playing around with a new piece of technology, it's like, fine, let's do that. Yeah. You know what I'm going to try it on? I'm going to try it on Lego bricks, because why not? And recently I've been working with recognition, so Amazon recognition custom labels, and that is amazing. And I'll pop a link somewhere, and people can have a look at the YouTube video I've done about that as well. Looks very similar. The app that I've done for it is basically the same, just goes to a different endpoint. So yeah, I'm not sure whether I will actually get around to expanding this model out very much, but maybe I will. Maybe I will. See, people want me to. Vote for your favorite brick for me to add.
Mike, just an idea. Crowdsource the labeling process of a new label bricks and a new Lego bricks. And maybe on your app, you can actually ask for feedback. Oh, did you get it wrong? And what is the actual name? And you can get them to type it in.
Not a bad idea.
Then
so
you have
the original data set coming from the synthesized data is, I guess, the main point. But to refine that further, absolutely build in some feedback process to it.
Yeah. So guys, download the app. Yeah. Give Mike some feedback. Yeah.
It's just a web page. There's nothing to buy or anything. It's just.
Okay. So wow. Another question: how efficient and robust is the machine learning model to identify the partially broken Lego pieces?
Okay, how robust is the machine learning model? You have just seen in the demo that clearly it didn't work to start with, so obviously it's got some issues there. What about with broken Lego pieces? No, well, if it's a broken Lego piece, it's going to look different, and it won't be able to classify that. The only well, I was going to say, if you're looking at the brick from an angle such that you can't see the broken part, then you're potentially still going to have problems, because it's if, for example, if I hold this brick here, which is a 2x4, if I hold it like that at the side, it's still a 2x4, but you right now can't tell what that brick is. If you can't tell what that brick is, then neither can the machine learning model either.
True. So, All right, thanks a lot, Mike.
I can talk about this all day, and we obviously are going to run out of time. If people want to sort of see more about this, if you want to sort of join me for more conversation about Lego or about machine learning or about anything else, then
and that QR code.
Come and have a look at me on LinkedIn. I got YouTube videos of other stuff that I want to show you as well. So
cool. So thanks for being here today, and of course you're going to be hosting for the whole day.
Around, yes.
Yep, and we'll be back shortly. Yeah.
Thanks, Chris. So, as I just mentioned, I hang around a lot on LinkedIn, and we have a lot of conversations there about everything and anything to do with machine learning. And it was actually on LinkedIn that I came across Ibsam, who is our next presenter. Some really awesome looking demos. Ibsam is an electronics and telecommunications engineer and currently works as a data scientist at AI Australia. She has a master's degree in the field of data science and have been involved in data analysis, data exploration, data visualization, and data pre-processing, where she plays with data to make useful and meaningful insights. She has solid knowledge in building data models. So she says, we'll have to quiz her about this. She wrote this. And applying learning algorithms to both supervised and semi-supervised learning projects. She's really cool. I can't wait for you to see this video. John, let's roll the tape.
Hello everyone, this is Ibtisam Sheikh. First of all, I want to thank you for having me at this session. I would also like to thank everyone for taking the time to attend this event, AWS Community Days 2020. And I welcome you all, and I hope everyone is well, staying safe and healthy. So let me briefly tell you about this presentation. This presentation is going to be showing how I performed sentimental analysis and how I detected emotions of a person in a video using Python and machine learning. Also, I'm going to talk about my journey. So let's get started. So who am I? I'm an electronics and telecommunication engineer, currently pursuing Master of Data Science and will soon be graduating. I also work as data scientist intern at AI Australia. I have experience in using Python to build machine learning models, preparing data, cleaning data, handling big and unstructured data sets. When it comes to data visualization, I have experience in using Python, Power BI, and Tableau to visualize data and gain meaningful insights. I am also machine learning and data enthusiastic. You can connect with me over the LinkedIn. I would love to interact with you all. So what's agenda for today? First of all, I'm going to tell you my story. How being an electronics and telecommunication engineer, I ended up choosing career in the field of data science. Then I'm going to talk little bit about artificial intelligence and machine learning. Then I'll be discussing my project, which is video analysis, the overview of my project as well as demo, and what challenges I faced and what were the solutions. Then I'm going to briefly talk about Amazon recognition. Last but not the least, I'm going to talk about what are applications of my project. So let's begin with my story. As I mentioned earlier, I'm an electronics and telecommunication engineer. During my bachelor's, I came across an article about this person named DJ Patil, who is the first US chief data scientist, and I was really inspired by his mission, which was unleashing the power of data to serve American people. And I started thinking about it more, and that's when I actually found that I was in love with data science type problems. For example, I remember sending a text message out to every friend of mine and recording the time distribution of when they responded. I always thought that predicting human behavior is such a cool thing, and that led me to data science. Artificial intelligence and machine learning, they provide the opportunity to catch a glimpse into the future. And I thought, why not contribute to those great things which is yet to come? Besides data science, deep learning, machine learning, and artificial intelligence are all the best way to create smarter and better world. Also, machine learning going to replace 30% of jobs in near future, and why not train such machines then to be replaced by them? I love data and machine learning because data allows us to make informed decisions and to stop guessing. I was never fond of making decisions based on my gut feeling because the gut says one thing one day and something quite different the following day. But data is what it is. With machine learning, we can take in unlimited data than previously possible to map out trends that will increase our understanding of the universe. I still have an enormous path to conquer, but the journey has been quite fun until now. And I'm really excited to see how these technologies will change our lives. And that brings me to our next slide, which is artificial intelligence. Artificial intelligence is one of the emerging technologies. From Siri to self-driving cars, artificial intelligence is progressing rapidly. The other day, I watched one of the interviews by Google CEO Sundar Pichai, in which he mentions that anytime you work with technology, you need to harness the benefits while minimizing the downsides. And we have seen how AI makes our lives more efficient each day, whether we are trying to read our emails, whether we are trying to get driving directions or music. AI helps us every day through digital assistants such as Amazon's Alexa, Apple's Siri, by performing various tasks from checking our schedules to sending commands to another apps, and the list goes on. AI is an important part of these apps because it learns from every single user interaction. When it comes to AI advantages, there are so many of them. For example, AI reduces human error. It makes faster decisions and is available 24/7. AI is truly transforming the world. And that brings me to our next topic, which is machine learning. Machine learning is the core sub-area of artificial intelligence. It makes computers get into a self-learning mode without explicit programming. When fed new data, these computers, they learn, they grow, they change, and they develop by themselves. And that is so amazing. Machine learning field is continuously evolving, and machine learning as technology, it helps analyzing large chunks of data, easing the task of data scientist in an automated process, and is gaining a lot of prominence. Machine learning has changed the way data extraction and interpretation work by involving automatic sets of generic methods that have replaced traditional statistic techniques. It can produce accurate results and analysis by developing efficient and fast algorithms and data-driven models for real-time processing of the data. Machine learning is taking over the world. It is benefiting companies across industries. Not only that, it is also helping organizations create systems that can understand, that can learn, that can predict and operate on their own. And our next slide is video analysis. So this is the project I have worked on, which is a video analysis. it was so fun doing this project and I enjoyed a lot. I got to learn so many things. So the task which I performed in this projects are detecting emotions from a face of a person in a video. Emotions such as happy, sad, neutral, surprised, stressed. I also converted voice part into text and performed sentimental analysis based on the text. The main tool which I have used is Python, and some of the main libraries I used are Keras, natural language processing, speech recognition. So first, let's start with demo and then I can discuss my code and other details of my project. So as you can see that my model did not detect my sad emotion. Maybe I wasn't sad enough for it to detect. That was the main challenge which I faced while doing this project. I'm still working on my model so that it would detect my sad emotion, and I'm also trying to integrate my code with AWS, that is Amazon Recognition, to see how it goes. This project was not my part of coursework. This was more like I wanted to learn and explore machine learning algorithms and AI. So let me discuss with you all my code and how I completed this project. So let me show you how I detected emotions. So this is my code. I have installed all the required libraries. I have imported load model from Keras models. Keras is a neural network API written in Python and is integrated with TensorFlow. Then I have imported image from Keras processing, which is used for loading images. Then I have imported image to array from Keras pre-processing image for converting a loaded image. Then I have imported CV2, which is used for detecting face in an image or in a video. Then I have imported NumPy as well. I have imported tokenization, stop words, sentiment intensity analyzer, and lematizer from NLKT libraries. This is useful for detecting sentiments, basically performing sentimental analysis. Then I have also imported some basic libraries. I have also imported a speech recognition, which is used to decode the human voice. Then I have imported audio segment from PyDub, which is used to load, manipulate, and save audio. So for the first part, I'm identifying most prominent sentiments based on person's face. Example: happy, stressed, neutral, sad. So for this, I have used Cascade classifier, in which I have used har cascade frontal face.xml file. This is designed by OpenCV to detect the frontal face of the person in the video. So after that, I have loaded the model, which is emotion.h5. It is a compiled model which is like ready to be used, and h5 is a file format to store structured data. It's not a model by itself. Keras saves model in this format as it can easily store the weights and model configuration in a single file. Then I'm reading a video file. Then while the camera is true, I'm getting every single frame of the video. Then I'm converting image from one color space to another, and then I'm finding faces, and then I'm making a prediction. And if no face is found, then it will return me that no face is found. But when it's there, it detects the emotion of the person. And when the camera is false, it doesn't show the output. You can also detect the emotions of a person through live video. Like you can give the import as your web camera, and and then it will detect the emotions. Then second part is converting voice part into text. For this, I have converted my MP4 file into WAV file using a function. Then after converting, what I have done is I have initialized the recognizer, which will actually convert my speech into text. And then this is my text. I have the text, so I would be performing sentimental analysis. Sentimental analysis is where the input is phrase or a list of phrases, and the classifier is required to tell if the sentiment behind that is positive, negative, or neutral. So I'm saving my text into txt file, and then I'm reading my txt file. Then I'm performing few tasks in NLP. So the first task is lowercase, where I'm converting each word to its lowercase. Then I'm doing tokenization, which is like splitting strings into smaller parts called tokens. Then I'm removing stop words. Stop words are words which are filtered out before or after processing of natural language data or text. Stop words are the most common words in any natural language. For the purpose of analyzing text data and building NLP models, these stop words might not add much value to the document, and that is why it is a good idea to remove them from the data so that more focus can be given to those words which define the meaning of the text. Other benefits of removing stop words are the data size decreases and the time to train the model also decreases. Even search engines, they remove stop words for fast and relevant retrieval of data from the database. Then after that, I'm performing lemmatization, which is like the process of converting a word to its canonical form, meaning that lemmatization, it considers the context and converts the word to its meaningful base form. After that, I'm detecting the emotions from the words. So for the purpose of this task, I have manually created emotion text file which will detect the emotions from the words. For example, if there's a word confused in the text, then the emotion related to that word is surprised. If the word is worries, and the emotion related to that word is stressed, and likewise. Then I'm counting the number of emotions that has occurred in the text, and then I'm performing the sentimental analysis using sentiment intensity analyzer, which will tell me whether the sentiment is positive, negative, or neutral. In this case, the sentiment is positive. And that's pretty much about my code. And my second last segment is Amazon recognition. So what is Amazon recognition? It is a developer tool with several different functions, including facial recognition, facial analysis, or sentiment analysis, and it requires no machine learning expertise to use. User can identify not only people but objects, text, activities in images as well as in videos. There are plenty of more things that recognition can do. And I'm really looking forward to get started with Amazon recognition. As far as converting speech to text part is concerned, Amazon Transcribe makes it easy to add speech to text capabilities to users' applications. Amazon Transcribed uses a deep learning process called automatic speech recognition ASR to convert speech to text quickly as well as accurately. And my last segment is applications of emotion detection. The first one I would like to point out is marketing or advertising sector. Customers want to know how people respond to their product, their packaging, their ads, etc. And sentiment analysis is very helpful in this case. Next one is education. Education applications measure real-time learners' responses to and engagement with the educational content. Emotion detection can play an important role in security as well by identifying people and monitoring their suspicious behavior by tracking their age, gender, and current emotional state. There are many other sectors such as hiring, clinical diagnosis, surveillance, where these technologies can be quite helpful. To summarize, the future of emotion detection is promising and the technology will become more widely adopted over the next few years. Whether it's analyzing text, video, or spoken conversations, being able to create actionable data with minimum effort in real time could change the way businesses approach user interactions in the future. And with that, it's end of my presentation. So thank you again. I hope you enjoyed my presentation.
One of the things I absolutely love is these highly visual demos of machine learning. So awesome presentation. And I'm so excited to say that Ibsam's with us here in chat. Hello.
Hi, how are you?
I'm awesome. Thank you very much. So thank you so much for this presentation. It's cool. We've had a lot of interaction on the Twitch stream, on the Twitch chat throughout this. So if you are watching on YouTube or Facebook, you should go over to Twitch so you can ask questions. And yeah, people are asking, who was it that asked this actually? Because I want to give a shout out to the people asking these questions.
It's
so
Lighter. Yep.
Yeah, Lighter928 is saying this notebook is very cool. Can it be shared? Can people grab this demo?
Yeah, actually, I can upload to my GitHub and then I can provide the link and then you can access this notebook from there.
That'd be
totally
awesome.
fine with me. Yeah.
No, thank you very much. Yeah, so if you want to do that, and we can if you do that later in the day, maybe even we can put that into the to the Twitch stream chat. People can go and take a look at it.
Sure.
But you're also big props to the fact you're owning LinkedIn right now. So I'm sure maybe when you could post it up there as well, and it would get sent
I
to
can
the
do
world.
that. Yeah.
And the next question is actually quite interesting. Can I use a sentiment analysis on my pictures to find out when my life is going downhill?
Oh no!
Wow. Okay.
That is so sad to hear that your life is going downhill. But what I think is that you can actually detect emotions. You're sad and happy. I don't think this particular code can actually detect any other sort of emotions. So if you're looking something to find if you're just happy or sad or neutral, then definitely this project will help you out in that.
Yeah, maybe,
sure.
maybe you can use it to take a photo of you multiple times in the past 3 months and then average them, and is it the trend going downhill or uphill?
Guys, I think there's something deeper going on here with this person, and we reach out to you. You're part of this community, so you're not going downhill.
Yes, you're not alone. Great on.
Yeah.
You're not alone. Yes, reach out. We're here. I have another question here as well. This is Calvin Code has asked this question, and they're asking about stop words. So you mentioned stop words in presentation. What
Yeah.
about translating all stop words?
I don't know exactly what does what do you mean by translating. What I know is you can remove stop words. And I mentioned in my presentation as well that stop words are the words which are filtered out before or after processing of natural language data. So it is always a good idea to remove them from the data, so the more focus can be given to those words which define the meaning of the text. There is not anything like which is related to translating. It is rather removing the stop words.
For sure. Yeah. So you're removing the stop words so that you can focus in on the actual meaning.
Yeah.
Okay.
Sure.
So the next question is from Ragnar. Any use cases of Amazon recognition and transcribe for dyslexic students use?
Actually, I'm going to explore that because I think there's a lot of valuable insights that I could gain by examining this particular area, and that's really not a concept that I'm really familiar with yet because I'm still trying to explore and learn. But this is like something I'm really excited about, and I have been like actively trying to learn more about it. So I don't think I have the best answer to that as of now.
So watch for Itasam next year in her next year session.
Yes.
It's a hint to you, Itasam. Yeah?
Come back next year with that.
Yeah.
So
Yeah.
so what projects are you working on at the moment? What cool things are you doing?
Okay, so there's this one project which is LinkedIn Analyzer, as I have been very much active on LinkedIn. So I'm part of this project where you give scores to LinkedIn profiles based on their profile picture, their about section, their experience, their work history, all sorts of things. Not only that, actually also recommends you on how you can actually improve your LinkedIn profile. So that is one of the projects. The second one, which I would like to talk about, is object detection. This is a project where you actually detect what sort of objects are there, on road. Basically, it's more related to traffic. When there's a traffic, you need to know what are the objects over there. So this project basically uses CNN, that is neural network, to detect objects such as cars, trees, people, you say light, poles, and all sort of things. So that project, I have recently started working on that.
Awesome. So what's the outcome of that object detection? What's the eventual goal?
The eventual goal of that project is if you're using a drone or something like that, then it is very useful to detect what all sort of objects are there, and accordingly you can
For sure.
decide.
To stop your drone from crashing into things. Maybe. I don't know. That's one useful part of it. Yes.
So
cool.
Next question. It's a bit technical question this time. Yeah. And on your talk, you mentioned that you're using HAR cascade for to extract facial features, right? Have you experimented with the CNN instead of using HAR? And what is the pro and con? And if you can actually elaborate more on that.
Okay, so I have not experimented using CNN to extract facial features in my video because I think it really depends on your task. One may be a better fit than the other. HAR Cascade is good at detecting lines and edges, which makes it really effective in detecting faces. For example, even if the image is blurred, it would be able to detect the eye. The limitation to Har cascade is that it can detect objects which have only like clear edges and lines, meaning that if you cover your eyes with sunglasses or you move your head to the other side, then Har cascade may not be able to recognize your face. So on the other side, CNN is determined by training, and it has higher degree of freedom than Har cascade, meaning that it could recognize your partially covered face. Obviously, it also depends on the quality of your training data.
That's a very insightful answer. Thank you, Tasam. Yes.
Yeah.
Yes. So it's interesting that you feature engineering words into expression before feeding them into your natural language processing sentiment analysis model. Is there any reason you don't pass them directly into the AI model without this feature engineering step?
That's a very interesting question. Thank you for that. Firstly, any machine learning algorithm or say AI model, it is based on principles of statistics, math, and optimization, right? So that makes them not intelligent enough to start processing the text in their raw form. So, and also how computers they process language is completely different to how humans process language. So it is very important to convert our text, that is input text, into something that our algorithms can understand, can easily understand. It also helps the model to catch like those exceptions which you any a significant interaction. And suppose even when you have like new source of information, in order to make a better model, you engineer features, and that is why I feature engineered words into expression before feeding them into my NLP sentiment analysis model.
For sure.
Yeah.
Look, thank you so much.
Yeah.
We got interest in the Twitch chat right now. People are very interested in your LinkedIn project. I am also very interested in your LinkedIn project too. So make sure that you keep us all up to date with that. Thank you so much
Yeah.
for that. Awesome presentation. And look, we'll be right back after this.
And we are back. The next speaker is Pratuya Sangam, and she's a data scientist at West Farmer Chemicals, Energy and Fertilizers. And Patty is a data scientist from Perth, Western Australia, and she's passionate about technology, coffee, and cats. Wow, yeah. And not necessarily in that order. Wow, okay. And she's a huge supporter of women in tech, and she spends a lot of her time outside of working to support the cause. And today, she's going to present the talk about don't dip a toe, but dive right into machine learning. And it's going to be another interesting talk. And without further ado, let's roll the video.
Hello everyone, I'm Pratyusha Sangam, also known as Prati. I'm a data scientist at West Farmers Chemicals, Energy and Fertilizers. Today, I'd like to share my machine learning journey, and I hope to inspire some of you to dive right into it. So here's an outline of what I'll be talking about today. I'll begin with a brief introduction of my current work as a data scientist and what inspired me to get into this field. I'll share some tips on how you could start, grow, and thrive as a data scientist or a machine learning engineer. I will also share some examples of how diving in headfirst opened up exciting opportunities, and made my machine learning journey enriching. As I mentioned earlier, I'm a data scientist at WestCEF. WestCEF operates 8 businesses in Australia. So far, I've worked on projects for Clean Heat's natural gas and electricity products, AGR's sodium cyanide plant, and CSBP's nitric acid plant. The best part about working in WestCEF is the varied exposure to different businesses, domains, and analysis types. My projects fall into the categories of business intelligence, which involves building dashboards to support operations, customer analytics, which is to understand customer behavior through clustering, segmentation, and prediction, and plant analytics, which is to use huge amounts of industrial IoT data to help automate and optimize operations in chemical plants. The types of analysis I work on can be broadly divided into these 4. The first one is descriptive. It is the simplest form of analytics. The purpose is to summarize the findings, to understand what's going on. It basically involves the usage of descriptive statistics, such as averages and percentages on existing data. Though simple, it's an important step to make raw data understandable to various stakeholders and managers. The second one is explanatory, also known as diagnostic analysis. It is used to determine why something happened. It uses techniques such as drill down, data mining, and correlations. It helps understand the root causes of past events and determine what factors contributed to the outcome. You could place these two under EDA, that is exploratory data analysis, which is crucial for the next 2 stages. The third type of analysis is predictive. This is where machine learning comes into picture. It uses statistical models and machine learning techniques, both classification and regression, to predict what is likely to happen. The fourth type is prescriptive. This involves optimization, that is, how to achieve the best outcome given a set of constraints. In my opinion, to be a successful data scientist, you must be able to do all 4 types of analysis. So, how did I get into data science? I started my career as a software developer in an IT consultancy firm in 2012. I worked on web development projects for several organizations in e-commerce, telecom, and banking. Typically, these organizations produce large amounts of transactional data. I often heard about how this transactional data was used to identify patterns in customer behavior. Some use cases I came across were recommendation systems in e-commerce, fraud detection in banking, and product bundling strategies in telecom. I was intrigued by the concept of data-driven decision making, and it stuck with me. Around the same time, I found the love of my life. I quit my job as a software developer and moved to China with my husband. I had a 6-month gap in my career, and I used this time to explore data science. I spent time learning Python programming and machine learning online. I decided I wanted to go a step further and get a master's in this field. I graduated with a Master of Data Science from University of Western Australia. I must admit, I followed a pretty conventional career pathway into this field. In my 4+ years in data science, I can say that not everyone needs to follow the same path. So how to get started with machine learning without formal education? Well, data science is an interdisciplinary field. It is about obtaining knowledge by using the intuition of domain expertise, validating insights using maths, and automating this process using computers, So basically, you need to know maths and coding to build machine learning algorithms. When you Google for the maths requirements for ML, calculus, linear algebra, and statistics consistently come up. For starting out, your knowledge of basic high school maths should do. You need to be familiar with statistics. You will need calculus and linear algebra at a later stage, where you want to understand how algorithms work under the hood. Knowing how to code is very important. Learning Python is a great way to start programming. Python is very easy to learn and is a popular choice for machine learning. When you're starting out, I highly recommend doing some research. Do some light reading on the history of ML, Industry 4.0, the applications of machine learning and its importance, as well as data ethics. It will help get some background and appreciation for the field. Follow online courses. I suggest going with something basic to start with. Courses that cover advanced topics in much depth may feel a little overwhelming at first. Aim at incremental gains. As a beginner, I recommend to focus on breadth and not depth. Try different algorithms and different types of problems. Start writing code now. Jump into it. As soon as you learn about an algorithm, I say get hands-on. This will give you a huge amount of instant validation and the push to keep going. Try Jupyter notebooks to test things out. You can pick ML tasks on platforms like Kaggle. Engage with a broad range of data sets to get accustomed to thinking about different domains. For example, you could look at medical, financial, sales, climate, or even sports data. Most importantly, have fun. Choose a domain that interests you. How to grow. Once you get a hang of things, take it to the next level. Start competing online. Several platforms like Kaggle, Driven Data, AI Crowd host competitions. Also keep an eye out for hackathons. Try to join a group and solve a problem. Collaborate with people from different fields. In addition to technical skills, that is the maths and coding side of things, you learn problem-solving skills this way. To be a successful data scientist, you need to know how to ask the right questions and find the key drivers. Pick a project of your own. You could build and deploy a model using Amazon SageMaker. A big shout out to Mike Chambers, who recently shared a project on classifying Lego bricks. Do fun projects like this. It'll keep you engaged and help you learn. Now that you have learned the technical and non-technical skills to be a good data scientist or a machine learning engineer, how do you accelerate your career? How do you thrive? You must be passionate, thorough with the basics, and willing to constantly learn and evolve. A great addition to your profile is to get certified. For example, you can do the AWS ML Specialty Certification. You could sign up to newsletters like Towards Data Science, KD Nuggets News, Towards AI, and Medium, or follow the latest research papers on paperswithcode.com. Give back to the community. I'm personally very passionate about supporting women in technology. I also spend time mentoring aspiring data scientists at the University of Western Australia through industry panels and events. To succeed, learn, grow, and repeat. Continue participating in competitions. Keep trying things that you have never done before. I'd like to share an example of why diving deep is a recipe for success. Last month, I came across this session called AWS Deep Racer League, organized by SheBuilds. For those who aren't aware, Deep Racer is the world's first global autonomous racing league driven by reinforcement learning. I joined the session to learn something new. I never worked on reinforcement learning before. It looked like fun, and it was free, so why not? We started off with an introduction to ML and reinforcement learning, RL, followed by deep racer overview and all the basics we needed to build the racing model. We were taught how to use the deep racer console and how to set up a vehicle and how to write the reward function using the various hyperparameters. We were given a week of hands-on time to work on our models. We got tips and a lot of support on a Slack group throughout the week. At the end, we submitted our models to the community race. I think this session was the perfect setup to learn ML. We immediately put our skills to use as we learned it. It was fun and rewarding. I work full time, so I had to capitalize on my evenings. During my hands-on week, I did research on the hyperparameters, what people have done in the past, and went through the material shared. I skimmed through information with a focus on breadth. I didn't have to be an expert in reinforcement learning to do this. My focus was primarily on how to use the hyperparameters to write the reward function, as everything else is basically managed by AWS. I spent time whiteboarding, buddied up with my husband to bounce off ideas. I made use of the resources, trained multiple models with variations. I was in it just for the fun, but I did it with passion and focus. What happened next was something I didn't expect at all. I came 8th in the virtual race. I won the final race, which was on a physical car. Along with some great Amazon Echo prizes, this gave me entry to the Deep Racer League at reInvent 2020. Winning is awesome, but the biggest takeaway for me are the opportunities that opened up, including today's talk. I found several mentors in the AWS community. It helped me find a new passion in reinforcement learning. It has also gotten me thinking about the applications of reinforcement learning at my work. Before I sign off, I would like to emphasize, don't wait to memorize the theory. Get hands-on with ML. Start coding right away. ML is an ocean, but there are numerous resources and lots of support. You can do this. Focus on small wins and incremental growth. Be passionate. Share, learn, and grow. Success will follow. Thank you.
And we are back here with Prati. Hi, Prati. Thanks for joining us for live Q&A. And we have, wow.
I brought Asher along just to
Yes.
say hi, because I know you're a big fan of cats, and I know you don't have a cat where you are. So Asher's currently trying to figure out what's going on and why she's here and why she can't go and sleep in the sunshine. So
she's really upset.
Wow. There's a very quiet cat, Mike. Also, maybe just today. He's quiet today.
What was that, sorry?
Was this a very quiet cat?
She is pretty quiet, yes. But we're not here to talk about my cat, but I just thought she'd come and say hello.
Well, Prati mentioned cat, so it's actually quite contextual. All right. So the first question here, what are the top 3 skills as the data scientist that you think is very important?
Yep. I think the first one would be ability to solve problems, problem-solving skills, to be able to understand a problem, come up with a solution, given the resources you have. I'm hearing a little bit of a sound. Is that fine?
Yep, I think it's fine. Yeah.
Are you hearing an echo?
Yeah, I'm hearing an echo. All right. Anyways, so yeah, to be able to use the resources that are at your disposal and also think of resources from outside your organization that you could use to solve problems. The second one is your ability to code. So all these ideas that you've put on paper, you want to translate that into code. And the third really underrated skill, I think, is communication. To be able to ask questions, to be able to explain your solution to all kinds of stakeholders, pretty much everyone, without using a lot of technical jargon, I think is very important. In one of the talks earlier today, I think Brad mentioned how important humans are to machine learning. So you want to make your models interpretable, and you should be able to speak about them. I think these are the top 3 skills that a data scientist should have.
That's a very great advice.
I love the answer because I like that, it's not you need a maths PhD. There's so much more to it than that. I really like that answer.
Yeah. I think humans are at the center of data science. It's really important to take into consideration that aspect.
Until one day your AI can talk to human.
Yeah.
So we need someone to be able to interpret it now.
Yeah, for sure.
All right. So you obviously have a lot of knowledge and thoughts in this space. What do you see as the sort of the future of machine learning? Maybe machine learning and data science. Where are the jobs going to be? That's what we want to know.
Yeah, for sure. We can expect a lot of jobs in machine learning and data science in future. I just read an article that came out yesterday by Australian Computer Society, which said we need 3,000 data scientists in the next decade in Western Australia alone. I know this is more of a local example, but at a global scale, we are currently in the 4th industrial revolution, also called Industry 4.0. Basically, we're producing huge amounts of data at a global scale, right? Just think about yourself. Your Twitter, your Facebook, your Instagram, your Fitbit, you're producing huge amounts of data. You're shopping online, you're interacting with these different systems online. And we need data scientists to be able to interpret this data and, hopefully make the world better in future. So for sure, yeah, there is a lot of future in this field. And if you're thinking about it, just get into it.
Absolutely. I really like that sentiment. I feel like 10 years ago, everybody was about big data and we want to gather all the data. And now we're kind of going, probably should do something with that data.
Yeah.
Maybe that's what we're seeing happening now.
Yeah.
And Brady, you know that the AI landscape is moving very fast, and now it's getting easier and easier by day to build AI model, especially with the high-level tools like SageMaker and all these high-end high-level frameworks. So I'm actually curious, how important it is to actually understand the algorithm behind the scene of this technology at the current moment.
Yeah, well, at first, when you're building models, it may not be as important to understand the maths behind it. It's not necessary maybe to know how to do partial derivatives, for example. It may not be necessary, but it is really important to understand the theory behind machine learning models. You may notice that, say, an XGBoost model works better at classification than maybe a logistic regression, and you want to know why that is. Understanding algorithms under the hood, maybe not the math, but understanding the concepts is definitely important. Again, it ties back to the first point that I mentioned. You should be able to communicate what your model is doing if you want it to be used and if you want people to trust it. So I think it is important to have that interpretability.
Very human, very human. So we have a question coming here from Greytone, who's asked some questions today on the Twitch channel, on the Twitch chat channel. And I don't know if it's fair to throw this at you because it's asking for specific information. So maybe we could all talk to this. It says, I work with GIS dev, which I'm assuming is geospatial data. Do you have any machine learning work in this field for inspiration?
Yes. So as I mentioned earlier in the talk, that I work for a conglomerate. One of the businesses that we have is called Decipher. It's basically an ag tech product. So looking at satellite data to understand what amount of fertilizer you need to put on your paddock, for example. So it's using the satellite information to try and understand the NPK values, the nutrition values in agriculture. So that's one example where you can use data.
That's a very interesting use case. Yeah.
I love that whole area of ag tech, by the way. I think it's fascinating to be able to use machine learning, but also just data and technology and drones to be able to help this growing problem, I guess, of feeding the world.
Yeah, making farming more efficient. Yeah, so we can actually reduce the wastage. Yeah.
Specifically geospatial data, it's widely used in mining as well in WA for a lot of exploration. So that's another use case. But I'm happy for you guys to pitch in as well.
No, I think that's brilliant. I don't particularly have one, so yeah, I'm glad you had one.
Me too. So let's move on. The next question is back into the ML general ML. What are the different phases of a data science ML project? If you can actually give us the breakdown and what's the importance of each?
Yeah. Well, it can change from organization to organization, but typically you do a requirements gathering, you have a project ideation, you have a problem, and you think that you're going to solve this using machine learning. Then you look at the data you have, the resources that you have. You do exploratory data analysis, which is basically doing summary statistics and diagnostic analysis. Then you perform data cleaning and feature selection before you build your model. You build your model, that's actually the easy part. The steps before that are kind of the hard ones. Then you do model evaluation, choose the best model. Sometimes at work, we have many models that perform kind of average. We try and ensemble them to get a better performance. Around the same time, we also build a visualization layer because end of the day, you want someone to interact with your model, use it. For instance, the Lego model that Mike built, there's an app which you can use, interact, right? So similarly, within our organization, we may have, say, Power BI dashboards where people ask questions and there's a model running on the background and it just gets displayed. And well, we have the model deployment and maintenance. That would be the last stage. And there is iterative improvement. Yep. We spend most time, I know in the age of AI, we shouldn't really say this, but we spend most time in data cleaning and feature selection. That being said, that is because I work in an organization which basically deals with explosive chemicals and human data, and you don't want to take any chances. So we are very thorough with this stage.
For sure. I think I've often said it as well, that the machine learning is the easy bit, it's the data that's the hard bit.
Absolutely.
Now, I'm also seeing things happening in I am conscious of the fact that there's a discussion happening in Twitch at the moment about trying to replace me with Asher, and we won't be dealing with that. Paddy, just I want to ask this question. I want to touch on this area. I think it's a fascinating area, interested in your insights, and that's the ethical considerations around designing machine learning. There's a huge topic there, but maybe just pick off a piece.
Yeah, I think we really get excited about machine learning, the algorithms itself, but I think it's really important to take into consideration the ethics, especially when you're using things like age, gender, ethnicity, and especially if you're using this model to make decisions that can potentially put someone at a disadvantage just because of their age, for example. Sometimes it is essential to use this information. For instance, you're building a model in medicine that can help detect a rare disease, and things like age, ethnicity are very important to this model. You're basically trying to save their life, and it is important to use these features. Even in businesses, you could use such information. For instance, you found out that people above the age of 60 are not very interactive with your website, for example, and you want to try and find out why. This can really help improve your process. So the ethical consideration comes to when this affects their life or it puts them at some disadvantage. I think that's where we need data scientists to think about whether or not they'll put these features into their model. It may give great accuracy, great performance, but from a commercial perspective, you want to improve your current process. Maybe you're not looking for something that gives you like 100% accuracy. So you need to take ethics into consideration for sure.
Yeah, for sure.
Cool. Thanks a lot. Paddy. So
we could talk about that for hours, by the way. And I would, yes, we'll have to do this again. But yes, it's a fascinating subject.
So thank you for actually joining today, and we'll be back shortly.
One thing you cannot escape from, of course, is COVID-19. It's the reason why we're sat here on this stream rather than maybe being somewhere in person. And so it's affected all of us, and it is got a lot of data around it, and it's an area that lots of people are interested in exploring. And so that's what we're going to look at now. We've got a video coming up from Vivek, who has just graduated as bachelor's in computer science from India. He is 15 times multi-cloud certified. So he's one of those people, very knowledgeable, and an active speaker, mentor, researcher, and blogger in artificial intelligence, cloud domain across various developer groups and conferences across India. Besides that, his Instagram bio suggests that he is a geek guitarist. So again, we've got more musicians coming on. We're going to have to talk about that. Loves binge watching Netflix. That is something we can probably all relate to. And speaks terrible French, apparently. So that's how you qualify that. But we'll talk to him more after his video, which is coming up right now.
Hello everyone, hope you're having a great time at AWS Community Day, Australia and New Zealand. I am Vivek Raja from India, and I'll be presenting the session on detecting and visualizing COVID-19 pandemic public sentiment using AWS Comprehend and QuickSight. I know that's a very long topic, but I will keep it as interesting as possible throughout the session. So before going into our talk, I want to give a big salute to all frontline workers of COVID-19, who are doctors, policemen, reporters, and servicemen, who are helping us to keep us safe and making our lives much easier during this pandemic situation. The agenda of the talk will be as follows. Like, we'll be discussing about COVID-19 and the lockdown measures and the psychology associated with it. And followed by, we'll be jumping into a solution part where we'll be orchestrating the AWS services, within which we'll be collecting the data, setting up the environment, and extracting the sentiment, and finally we'll be visualizing it. About COVID-19 or coronavirus disease, I don't think there is a need for an introduction for that, as everyone is much aware of it. But taking India as my case study, I want to discuss about the various measures and the policies that was implemented by Indian government to control the outbreak of coronavirus. So the first COVID-19 positive test case was recorded on January 31st of 2020, followed by there was a drastic increase in number of cases, and the Indian government implemented lockdown 2.0 on March 25th with various strict policies and measures. Followed by there was a lockdown 2.4 on April 15th, where the lockdown was much more strict and it was implemented with full force, and followed by 3.4 on May 4th and 4.4 on May 18th. After that, the Indian government witnessed a few relaxations, and the policy was little down relaxed, and the unlock 1.0 was implemented on June 1, and unlock 2.0 was implemented on July 1st. And this continues as till present. I know that this lockdown is one kind of a situation we have never experienced before, and with this, we have a lot of emotions and other things associated with that. People are tending to experience isolation, loneliness, depression, and sadness due to this unaccustomed situations. But on the brighter side of it, people do experience positive insights like spending a good quality time with their family, which they haven't done in a long time because of their work and other issues. And with coronavirus outbreak, there is a very big impact on our lives, whether it be it a health, career, or financial statement. So, on economic perspective, there is a recession going on, and many people have been fired from their jobs, and businesses have been going down, and a lot of things have been happening due to COVID-19. But it's we can only hope that this will end very soon, and we'll be able to come out of it. Now comes the solution aspect of our solution. So first, we will try to orchestrate the AWS services, and we will see how that can help us to bring out the solution. So we'll be using social media content for analyzing how the sentiment of the people were during the lockdown situations. So there are many social medias where we can leverage the data from, but I feel that Twitter is a legitimate one. Also, a lot of people are engaged in Twitter, and it's much easier to collect the data from Twitter as compared to other social media handles. So we'll be collecting the tweets, and we'll be storing that in a S3 bucket. So once we have the data in our S3 bucket, it will trigger a Lambda function. That function will do the rest of the thing. So it will collect the data from the S3 bucket, detect the sentiment of the tweet, and populate the results in DynamoDB. So once that is done, we'll be able to visualize the data and the respective sentiment from the DynamoDB in Amazon QuickSight. So now let's jump into the data collection part. As I had said earlier, we are using Twitter as our data source, and for that, to collect the required data over a span of several months, I don't think the Twitter API would be the perfect choice because it only allows us to collect data for past 7 days. But in our solution, it requires around 6 to 7 months. Yeah. So I went for another Python library called Get Old Tweets 3, which is a Python 3 library to collect the tweets based upon various parameters such as location, date, and hashtags and keywords, and so on. So we will see how we are collecting the data in a couple of slides after this. And to pre-process the data, we are using a typical Python library such as NumPy, Pandas, JSON library. I want to mention that the whole tweets will be extracted on the form of JSON, and for us to work conveniently with that, we'll be converting that into a CSV data frame using Pandas, and at last we'll be exporting that as a CSV file, which will be much more easier to us to access. So there are 4 criteria upon which the tweet was collected, and the first thing is English. The language of the tweets were confined to English language. And the reason is that India is a multilingual country with people speaking a lot of languages, and they come from various regions. Uh, with that, given that as our scenario, I don't think the sentiment analysis part doesn't really is compatible with other languages. So let's stick with English for our easier perspective. And second one is cities. We need to concentrate on the cities where the tweets are generated on large number, and we do that exhibits real sentiment of the whole region associated with the city. And the third thing is the date ranges. Obviously, you can guess that the date ranges associate with the lockdown dates that was implemented by Indian government. And the fourth one is the keywords. So what are the specific keywords we need to look upon to extract the tweets? So we'll be seeing that. So once we have set the tweets as English, now we need to concentrate on the cities. So I have selected 6 major metropolitan cities of India, which is New Delhi, the capital of India, Kolkata on the eastern side, Mumbai on the western side, and Hyderabad, Bengaluru, and Chennai on the southern side. To make sure that we include almost all regions of India, I have set a radius of 100 kilometer per each city. Let's say like as you can see on the map, it covers almost the entire country here. So that will really help us to analyze the sentiment regardless of the region and the place where the people come from. And the third criteria is the date ranges. It, as I said before, it parallelly matches with the lockdown and the unlock measures dates. So I have set the pre-lockdown as a date from which the first positive test case was recorded, and the date before the lockdown one was implemented. So that's our pre-lockdown, and the lockdown 1, 2, 3, 4 will be the dates respectively, and the unlock will be like after the lockdown period. Now comes the keywords. So we have an enormous number of tweets where users are posting on daily basis and it covers all type of domains and messages. So to capture the sentiment of the people, we need to pick up the best 10 15 top trending keywords and hashtags. So obviously you can guess COVID-19, coronavirus, health, job loss, or or the top trending keywords associated with this. So now that we have collected the data and we have set up the all the pre-processing things were done, and we have a CSV file with us, now it's time for us to set up the environment in AWS. In AWS, first things first, we need to create an account. So if you don't have one, you can go and create an account within a couple of minutes. And whatever we are discussing so far in this tutorial or the session will be more or less in the free tier. But I do give a warning that there might be some situation where you might incur additional cost. So keep an eye on the billing section of the AWS to make sure that you don't exceed the free trial. So once your AWS account is up, and you need to create an IAM role. And for this role, you need to attach 5 policies or 4 if necessary is enough. And these are the services we are going to be interacting with in the solution part. So we need DynamoDB full access, comprehend for sentiment analysis, Lambda execute for executing our Lambda function, and CloudWatch logs to see the logs of the Lambda function, and so on. So RDS data full access is optional, but I would say like we had included it in this policy here. So we have set up the role, and now we need to set up 2 storage tools. One is the S3 bucket for the input data and the DynamoDB for the output data. Please make sure that you're not going to upload your data now, but you are just going to create the necessary tools. So go ahead and create a new S3 bucket. I don't think there is much sort of a explanation needed for that. And when it comes to DynamoDB, create a table, and you can name the table as you want, and set text as our partition key. So the reason why I'm saying text as a partition key is that text refers to the tweet text of our data. So now comes to the part where we extract the sentiment. So our Lambda function will be working as follows. So the Lambda function will be triggered whenever a new object is created in an S3 bucket. So the first thing is that we need to set up a trigger for our Lambda function. So that will be a new object creation in S3. So once that is done, the Lambda function will be triggered. So the Lambda function will be fetching the data from the S3 bucket, sending that to our AWS Amazon comprehend, where we'll be extracting the sentiment of the tweet. And finally, we'll be populating the same in our DynamoDB. So the Lambda function runtime will be Python 3.8. And first, let's see how we are going to define our Lambda function here. First, import the necessary packages, OAS and JSON for manipulating and playing with the data, and Boto3 for enabling the access to the AWS services. And as you can see, Boto3, we are implementing the client, comprehend client, and we are importing the resource for DynamoDB, and we are referring the table, DynamoDB table COVID sentiment, so which is your output DynamoDB table. The name can be as you wish, and you can change accordingly. The second is that we need to set up the trigger. So you can set up the trigger in UI part, but the handling and the respective trigger code must be as follows. So under the Lambda handler function, so the event is the one where a new object is created in S3 bucket. So when that event occurs, we'll be trying to get the bucket name and the new object that was created, that is our file name. So once we get that, we'll be able to read the content of the entire CSV file using a dict reader. So let's define the reader as well. So once these are done, the next thing is that we need to extract the sentiment and populate it, the results in DynamoDB. So that can be done in a couple of lines. So we need to iterate the reader row by row, and we'll be like populating the DynamoDB as 4 columns to be document. So the document consists of text, which is the text of the tweet. Location refers to the city, and the phase refers to whether it is a pre-lockdown, lockdown, or unlockdown. And the sentiment is where the sentiment of the tweet. So here we are calling the detect sentiment, where the sentiment is detected, and the tweet is sent as an input, and we are extracting the sentiment alone here. So once this is set up and done, you can go ahead and upload the CSV file in your S3 bucket, and the whole thing will be triggered, and your results, final results, will be populated in your DynamoDB. So now it's our turn to visualize what type of results we had got. So for that, we will be like using uh, uh, Amazon QuickSight for that. So to export the data from the DynamoDB, you can use AWS CLI, and with this just one command, you will be able to export the entire data in your DynamoDB. So the reason why I'm exporting the data here is that it's one of the easier way to do it, and you can re-upload the same data in your Amazon QuickSight. So go to your Amazon AWS QuickSight, and in that, for the new data source, you can go ahead and upload the exported CSV file here. And now it's time to play with the data. So as you can see, I had selected a histogram to represent the data where it's pre-lockdown, lockdown, and unlock here. We can also notice that though the neutral is one of the major tweets are conveying to us, we can also specifically note that the negative aspect increased during the lockdown period, and the positivity increased during the unlock measure. So hopefully people are trying to be as positive as possible as the unlock measures are unfolded here. And this is another pie chart where it shows the count of each type of sentiment for lockdown measure. And now it's time for you to go ahead and play with your QuickSight dashboard. So it's very much easy. You need to export and select the respective terms, and you can visualize it as you want. And with this, solution is coming to an end, but it's not really the end of the solution. We can enhance it in much better ways. So there are a few suggestions from my side, is that we had now collected the data, the historic data, and we have visualized it. To make it a real-time dashboard, you can use AWS Firehose to stream the real-time data from Twitter to S3, and followed by this can be entirely done throughout the end of the solution, where we'll be having a real-time dashboard at AWS QuickSight. To help us to build a real-time dashboard, we can build a data pipeline between the data source, the result data source, and the AWS QuickSight data source. So instead of exporting it and re-uploading, we can define a data pipeline. So as I said that we can, it's not really to stick with DynamoDB. Instead of that, we can go ahead with any other DB like RDS I had discussed in the earlier part. And once your dashboard is ready, you can also publish it as a web app using Elastic Beanstalk. So if you have any other suggestions to improve the solution, please let me know in the comment section. To help you get started with this solution, I have uploaded the entire dataset in my GitHub profile. You can go ahead and search my username Vivek0712, where I have my COVID Twitter dataset. And also, I have written a step-by-step tutorial blog for the entire solution. And I have aimed to write that solution for in the beginner aspect too. So if you are new to AWS and you want to get started, I think this blog would be a great start. It's our responsibility to reduce the number of cases, and it can be achieved by ourselves. So for everyone, let's try to flatten the curve by wearing face masks whenever you go out in public. Use sanitizers and soaps to frequently wash your hands and maintain a social distancing of at least 2 meters between each other. I hope this session was informative. And if you want to catch me or have a chit chat or discuss about anything related to AI or cloud, I'm very much happy to discuss with you. You can catch me on LinkedIn at Vivek0712 or Twitter at VivekRaja007. I know that sounds like a James Bond. And my GitHub profiles have an amazing repos related to AWS and other machine learning repos. Do check it out at Vivek0712. Now you can post your questions. I'll be happy to assist you and give you the answers for that. And thank you.
Brilliant presentation. Thank you so much. Visualizing data there from the global response, I guess, to this pandemic. And we're obviously very grateful again, as we have been with all these presentations, to have the presenter live with us. Vivek, hello. Thank you for joining us.
Hi, Mike, and hi, Augustus. That was thank you for your amazing feedback.
Yeah, no worries, no worries. And you're in India right now, so you're not trapped in Australia currently.
But I do trapped in my lockdown measures in India. Actually,
you're trapped where you are. We're all trapped somewhere.
Yeah.
I want to talk to you about COVID and just on your personal experiences with COVID, because obviously everybody's got what I'm detecting as a thread throughout today actually is the human side of machine learning, whether it be the ethics or anything else. But obviously there's a very human story to your side too.
Yeah, actually, I do churn the positive side of this lockdown measures actually. So I do get a quality time to spend with my family. So everyone works from different places across India. So right now we are living together in one single home. So that's a really good way. And coming to my professional and career perspectives, I utilize this lockdown to enhance my cloud skills as well. So I took a few certifications from Azure, Oracle, and Alibaba Cloud, and I started exploring AWS. Wrote a couple of blogs, and I gave a few talks in various conferences. So that's one of keeping my positive skills ahead during this time of pandemic.
Absolutely, and I just need to get a big shout out. There's such an awesome AWS community in India as well. So it's a great place to be, no doubt.
Thank you. Thank you. I should convey that.
So now there are some interesting questions. One from Prady, which is the previous speaker, which is interesting. Yeah? And she asked if it is possible to track the increase of fake news in India during the pandemic.
Yeah, that's controlling the fake news using sentiment analysis or using the natural language processing is one of the research areas that is primarily being worked on. So how that solution works is that you take up the content that is being circulated in either articles from social media handles or any blog post across any websites. So you cross check that article with various headlines and other articles posted at the same time with the legitimate sources. So once you get a legitimate score that is above the confidence score that your news is valid and it is safe to publish and circulate among the public, and it's good to go. But since it's a very long process and people are pouring their own content inside the internet, there is a very high risk and a lot of space for monitoring. So it's kind of a research area, but still we can work it out, and that will be a huge benefit to everyone else.
Yeah, this is getting more and more critical, with the fake news and fake video, things like that, and it's going to go spiraling out of control, if there is nothing done to it,
Machine learning is going to take over the world. Machine learning to try and detect other machine learning that's creating the problem in the first place. So you're getting, obviously in that presentation, a lot of information from Twitter and looking at those tweets. Do you do any of the sort of pre-processing on the Twitter message before you use it to extract sentiment?
For my research purposes, I did few of my pre-processing stuff, as one discussed before in earlier one of the sessions, like lemmatizing, removing stop words, and so on. So these are one of the formal techniques that is used in natural language processing to pre-process the text. But when it comes to Amazon sentiment analysis, using Amazon Comprehend, there is not really a need for you to pre-process the data before feeding into it, because it does all the stuff by itself. But when we need to put a human kind of a perspective inside this machine learning aspect, then there is one thing we need to consider. You can also add the hashtag or specific keywords along with the tweets. Then that cannot be done with your Amazon Comprehend, but you can do that by yourselves. So doing that, few of your pre-processing steps by yourself before feeding into your AI services, that will really fetch you good results. And I have done that for my project as well. So to put you out of all the hassles of pre-processing stuff, I have pre-processed data set in my GitHub profile. I've shared the link in the chat box so that you can go ahead and use that for your research purposes as well.
Brilliant. Thank you for that.
And seems like whenever people doing a sentimental analysis, majority of them actually getting the data from Twitter, and it's very popular. Yeah. Just curious, is there any other useful data source apart from Twitter that you know of, yeah, for sentimental analysis?
Yeah, there are a few quite social handles which are primarily used for sentiment analysis. One is Twitter, obviously that holds the first place, and Reddit is one of the second place where we get a huge content of text related to every topic that is being discussed on the internet. So I would suggest you to go to Reddit if not for Twitter, or you can go for other handles such as Quora and other stuff. But when it comes to social media like Facebook or Instagram, something like that, you don't really have much of an access or an API access to fetch the text. So the best thing is to stick with Twitter, or if you need to have a more kind of a text information, go with Reddit or Quora. That would be the perfect choice.
For sure. Cool. So look, I want to ask you this question because I think you wrote it in your Instagram bio. You speak terrible French. What's the story behind that?
Yeah, actually, I was about to go to Canada for this couple of months, so I felt the need to learn French, and I took few online classes. That is during this lockdown to improve my French skills. So I managed to speak few of the conversational French as well. So I'm not so I can term myself as a terrible French speaker. That's it. So that's the backstory of that.
I think you need to reposition that. Is that you're currently learning French? That's okay to say.
Yeah, we can phrase it in a good way in that sense as well.
Absolutely.
So cool. your level of terrible is still better than me, which is 0.
Thanks for helping me to boost my confidence about my French skills.
Well, it's been awesome to talk to you. Thank you so much. Thanks for being up there at this time in India. All the best of luck. And yeah, look, we'll move on to the next presentation.
Yeah, thank you, everyone. Thank you, Mike. Thank you, Augustus.
And we are back. That was an awesome session just now, yeah, Mike?
Absolutely. Look, and I think the quality of all of these presentations has been great. Obviously that's a reach out from the Indian community. I feel anyway that the Australian community, Indian community, and other global communities, there really is a strong connection there. And COVID-19, for better or worse, has made that stronger, which has been really cool. But yeah, throughout today, I've been super impressed with all of the presentations we've had. Especially yours. Did you need to say that?
I want to tonight. I'm gonna rewatch all of them. Yeah?
Yes, absolutely.
In the comfort of my bedroom. All right. So without further ado, the next speaker is David Reedy, and he's a lead developer from UK. And his title of the topic is talk is interesting. Is Who's That? recognition in practice. And David has been programming since the 1970s. Wow, okay. He's a physicist by training, but has been a high school teacher for the past 35 years. Having never quite grown up, he still plays Dungeons and Dragons regularly. And as many SWSers will know, coding and knitting are intertwined. Wow, okay. And David once picked up a second place in the Sydney Royal Easter Show Fair Isle knitting competition. He's an interesting guy. And let's roll the video.
G'day everyone, I'm David Reedy, and welcome to my presentation, Who's That? Recognition in Practice. And welcome to the Blue Mountains, west of Sydney. This presentation was developed and recorded on the lands of the Darug and Gundungurra peoples. For tens of thousands of years, they have been the custodians of this place. I pay my respects to their elders, both past and present. Facial recognition has had mixed press over the past few years. It ranges from approval when it's used to unlock your mobile phone, to concern when it's used to identify people in the street. It is undoubtedly a powerful tool, and one that can add real utility when used judiciously in software. Let me explain where facial recognition fits into my software. I've been working on software for use in care settings, in particular aged care facilities. It's called UCare. If a facility uses UCare, it means that staff will be carrying an iOS or Android device with them during their shift. The software is primarily aimed at benefiting residents and their families, but that doesn't mean that we can't also include features to directly assist carers. If a carer is going to be carrying a device, there has to be a way that we can add value to their work. It's an unfortunate fact that the majority of residents in aged care facilities are affected by dementia to varying degrees. In some cases, this leaves a resident unable to identify themselves to a carer. And if the carer doesn't already know a resident's name, it can lead to uncomfortable interactions. This is where our use of facial recognition comes in. It allows a carer to identify a resident if the resident can't identify themselves. Or perhaps they're napping and the carer doesn't want to disturb them. So can we give a carer a way to identify a resident discreetly and from a distance so they can approach with a cheery, "Good morning, John," because they know his name? Of course we can. Amazon Web Services has recognition. Recognition has many features. It can detect and label objects in both still images and videos. It can detect and recognize text in images and videos. And a new feature added recently means it can identify personal protection equipment and work out if it's being used correctly. In UCare, we use it to detect faces in an image and to identify who a person is. There are two phases to building our solution. Firstly, a collection needs to be created which contains all the images of the residents. We call these reference images as they're also used as the identification image on a resident's record. The second phase involves capturing the image of an unidentified resident and using recognition to match it with the images in the collection. Let's start with building the collection. So when it comes time to do a reference image, first of all, we select the resident from the list that's available, we tap the record button, and we tell it we'd like to take a photograph. We then line the resident up, take the photo, as I said, using the normal camera app. We decide, yep, that's fine, we'll use it. We now make the decision about whether or not this image should be visible to other users. And if it is, we can say, no, we don't want to hide it. We go save, and that's the reference image captured. Before I go on, I should point out that any data or images that you see in this presentation are fictional. Residents' names and details were generated stochastically, and all the portraits are either stock photographs or pictures of family and friends who have given permission. We stored the reference images in S3. The folder structure we use has a separate folder for each facility, and that folder holds all the files for that facility. The reference images are stored in the reference image folder. I use this folder structure as it means that the files from different facilities are never mixed together, which provides better security. And because of the way recognition builds collections, it is very simple to ensure that a collection for a facility only contains images relevant to that facility. Let's look at the code that's involved in creating a collection. I'll be using an iOS device for these demonstrations, but the process is similar for an Android-based device or any desktop computer. The mobile code I will be showing is written in Swift. So let's have a look at some of the code. This is the code that provides the user interface on the iPhone. As you can see, it's fairly straightforward. This is all interface code. The only important things are really the take photograph button, which is down here. Tapping on the button simply says that we're going to want to see the capture image view. We do that just above there by toggling it, and we can see a little bit further down. That if we do want to show the capture image view, we simply call that view, which is here. This is even simpler. Basically, capture image view uses the inbuilt functionality to bring up the image picker. And in this case, we simply say we want the image picker to use the camera. And that's pretty much all there is. So that's very simple. The interface to our API is handled by our reference image class, which is one of the models. It's here. As you can see, looks really awful. That's mainly because I'm not using any third-party libraries to upload the data, simply using the inbuilt parts of iOS. So all of this stuff here really is just setting it up. We pass in the image, we pass in its file name. Down here, we set all the data up and encode image itself just here. And then basically using the inbuilt URL session, we send it off to the API and pretty much hope for the best. When it returns, it will execute the code that's here. We check for errors, make sure we didn't get anything other than a 200. If the image doesn't get there, we deal with that separately. Let's have a look at the server-side code. We have an API called upload reference image. It collects any of the reference images when they're sent up with a little bit of extra data. The part above this basically collects the information, checks that it's a valid connection, and then pulls it apart to give us a photo identifier. That's, in this case, the identification number that matches the resident. Photo type, just to make sure it is a reference image. We put that in there just to be sure. And some metadata. The metadata is used to tell us if this is a private image or not. And we'll look at that a little later on. What happens is that we transfer the file to S3, and then down here, we call our routine reindex faces. What this will do is add the newly uploaded image to the current collection. So let's have a look at that. Here's our reindex faces function. It takes a facility code. That's so it knows which collection to add it to. It takes an image name and it takes the ID of the resident, which is something that we're going to use as part of the indexing of the collection. We make the collection name, and all our collections are named with the facility code _collection. Don't worry for the moment about this rebuild collection. We'll talk about that in a second. First thing we need to do, though, is just to check if the collection exists. Now, for the very, very first person that goes in there, it won't. For everybody else, it will. But that's what we do here. If it doesn't exist, we simply create the collection at this point here. Again, just skip this next bit for a moment. We then point to the image as it is stored in our S3 bucket and call the recognition client with index faces, passing it the name of the collection, default detection attributes because it says to, the image ID, which will be the resident ID. That's what we will get back when we match against this face. Some other little bits, including the bucket that everything is stored in. We only want to index one face, so it will only add the first face to the system. And the quality filter, there's not a lot of documentation about it, but it says to set it to auto, and who am I to argue? And we just echo the result back. What should have happened at this stage, though, is that this new reference image has been added to the face collection and we'll be able to match against it when we do the matching. Having a look at that rebuild collection, it's really just here for debugging purposes. What it does is it removes the existing collection, then goes through all of the existing images that are in the bucket and rebuilds the collection. It's really handy for debugging. You, of course, do not want this in place when you're running production code because you can simply add individual images to the collection. You don't need to rebuild it from scratch each time. We take privacy very seriously in UCare. By using a long and random reference number to identify images, we help protect the privacy of the residents in our system. even staff who are maintaining the system will not be able to put a name to an image unless they also have query access to the main database. Also, if a mistake is made and the security of the S3 bucket is breached, no identifiable information is lost with the images. These images are used as a residence information page, but as we said, in some cultures, it's inappropriate to display images of a person. We handle this in the application by prefixing the string no-show to the file name. When searching for an image to display in the resident record, we don't add the string, so the file will not be returned. Instead, a generic image stating that the image is unavailable is returned. There are other ways to mark the fact that an image should not be displayed, but this way has two advantages. We could store the private images separately, but by using this naming system, the image files can be stored in the same folder as unrestricted images, making the regeneration of the collection data much simpler. Also, by tagging the file name, it is obvious to anyone maintaining the system with access to the S3 storage that these files should not be displayed. Let's now look at the fun part of doing all this work, identifying the person in an image. I'll use myself in this demonstration. I've already included a reference image of me in the collection, and I've given myself a fake name. When it comes to using the feature to identify a resident, the process is fairly straightforward. Once again, we capture an image of them. Because this is the normal camera app, I can use all the camera features. There's a lot more latitude allowed in this photograph, as recognition is pretty good at still matching people. It is important to note, though, that recognition will only match the largest face in a photo. So preferably a resident would be the only person, or at least the most prominent one in the photograph. Once you've got the image, we select Identify, and the work starts. Once recognition is finished, it reports that in this case, the person is Julian Blair, and that it's pretty sure. That means basically that it's got a confidence of better than about 95%. We can check that it got it right by tapping on details, and we can see that yes, it did match against my photo that I put in earlier. I would like to point out that I am not 98 years of age though. So that's how the feature is used in practice. Here's the server-side code for when we want to recognize a face. Again, the bit above here is collecting the data that's been uploaded and checking that it was an authorized upload. If the result is secure, that means yes, it was an authorized upload. We start by making sure that the temporary file exists. When we call this, the image file will have been uploaded and stored in a temporary file, which will disappear automatically when this routine finishes running. So we just check that it exists. We get the data out of the file. We don't do anything more with it in the way of storage, because recognition works better if you send it direct data rather than giving it a file to use. You can give it a file to use. It's just recommended in the documentation that you just hand it the data. So we do that. We make a new recognition client using our AWS credentials. We then use search faces by image, which is just a matter of passing in the collection, which hopefully contains the match for the image that we're looking for. And we pass in the image data, as I said, in this case, in the form of bytes. We should get back some face matches. As long as we get back more than 0 face matches, we can go on. We get the image ID of the first match. The first match will generally be the best match. We get the confidence level, and then we simply return, then we make up our return data, which is the image ID, which of course corresponds to the code number for the resident. And we append the confidence just as a tab delimited string. If there was no match, we return no match, and hopefully we don't ever have to return a failure. We then just send it on its way back to our mobile application. Back on the client application, the identifier is matched to the resident using locally cached data. An overlay with the name of the residence and a phrase expressing the confidence of the match are displayed. The user can then continue to the residence detail page if needed. One of the things that came up in early testing was that presenting the confidence as a number was not very user-friendly. So instead, we replace it with a phrase that better expresses confidence. Phrases range from "is pretty sure" to "is not confident." If the confidence is below 80%, UKED doesn't report the identification. These confidence levels may change once there's a wider range of faces in the system. Once we had recognition working, it was pretty clear that it could be used to really enhance some other functions of the software. Sending pictures of a resident and their activities to family members is a key feature of the software, but I had concerns about protecting the privacy of others who may appear in the background of a photograph. Rekognition has the ability to detect all the faces in an image, so the image can then be manipulated to blur out the faces of those that shouldn't be there. So let's have a look at using Rekognition to help keep photographs private. We take a photograph as normal. Decide to use it, and then edit for privacy. When we do that, the photo is sent off to Rekognition and it comes back with the faces outlined with little rectangles. To make the image private, in other words, let's assume that the two people on the left aren't meant to be in this photograph, we can simply tap on their faces. They'll be blurred. We can say the editing is completed. And now we have a photograph that we can quite happily send to the relatives of the two people on the right without infringing the privacy of the two people on the left. Here's the mobile code we use to process the image. But as this isn't a Swift UI talk, I'll keep this brief. We set up a crop filter to hold the original image. If all we were going to do was add the boxes, then there's an easier way, but we're going to do more in the next steps. So to add the boxes, we get the final image out of the graphics context, and then we just draw each of the rectangles and publish the updated image. Once the image is displayed, the user is able to tap on rectangles to blur or unblur the face, as we saw earlier. From the tap location, we can find the rectangle that contains the tap point and toggle the show status. Implementing the blurring is done by blurring the entire image. Then masking the blur with rectangles corresponding to the outlines we got earlier. Rather than using the exact outlines, we expand them by about 35%. As Rekognition returns closely cropped coordinates, and blurring just that amount looks a bit strange. For instance, you might end up with a person with a blurry face but perfectly sharp ears. We also feather the edge of the mask to improve the final appearance, avoiding sharp edges. If the user then decides to dispatch the image, we draw it without the rectangles but with the blurs in space. That way the stored image respects the privacy of those who have been edited out, and we then use facial recognition to dispatch the message to the authorized relatives and friends of the residents who are unblurred in the image. Machine learning is very powerful, but it's also quite complex to learn and set up correctly. Using the features of Rekognition makes it possible to include really powerful features with much less effort than if we'd started from scratch. But advanced features are just showing off unless they can be put to good use. I want carers, who are often really busy people, to use my application as often as possible. So it's essential that this extra work does not add an extra burden. Using Rekognition's functions will make a real difference to the quality of communication UCare can offer. If you'd like to contact me, those are my details. I hang around on Twitter a bit, so you can get me there, or there's the email and our website.
And we are back here with David Reedy with us live answering your question. And that's actually demonstrate a good use of AI, which is really noble and practical. And I'm actually curious, would you share a little bit with us? How did you come up with this idea in the first place, really?
Oh, well, this came out of personal experience. My nephew and I have the company that we make software with, and his grandfather and grandmother are getting on, and his grandmother needed to go into care, but George, his grandfather, didn't. And it was very, very hard on George. They've been married for nearly 60 years. And in that time, they'd seen each other pretty much every day for 60 years. And now his wife was 2 suburbs away and he couldn't get to see her every day because he just wasn't up to it. And it was very hard on him that he just wasn't finding out what was going on. And so that's why we came up with the software. At one stage, he said that, in one way, it would have been better if she had died because God would be looking after her rather than strangers that were 2 suburbs away. So that was how we came up with the idea for the software. We really do want to keep families talking to each other, or at least communicating with each other, and allowing for the fact often that the person in care is unable to use the technology themselves. That was how we came up with the product.
That's a really great vision, actually, Dave.
Yeah. And this area as well is under a lot of focus and under scrutiny now as well, I suppose, because of COVID-19, and it's been in the headlines quite a lot as well.
Yes.
What traction are you getting in the industry?
At the moment, not a lot. We're at the stage of getting ready to go into proper testing. The software's up and running. We would really like. I've designed the interface. It may not be what nurses and carers really want to use, so we really want to get some feedback from people about how does this work in the cold face rather than just my ideas for how to do it. We've spoken and shown it to nurses and managers. They think it's a good idea. We're now looking to take it to that next step and getting some real world testing done so that we can launch it properly.
Yeah. So guys, if you have some contact and you are in the industry, have a contact.
Yeah, it'd be great.
I think it's up. Sorry, I think it's up to us as well. A lot who have family members maybe in aged care as well to be promoting this message out and sort of saying that we want generally this industry to up its game, and there are some tools out there as well.
Yeah, cool. So now question. We have a few questions from the floor, and Rang Ray asked this. Will it help if some of the historical images of the patient to be used as well to better recognize the patient, as they may not appear at their best for just one single image?
Probably, although you don't need it. I mean, we've worked with our test images. Basically, we get a nice ID photo. Generally, with the aged care facilities, they will have a good ID photo on file just for their own records, and we can use those. Certainly we could use older ones. You really don't want there to have been a lot of change in the face, obviously. But but we've found just with one good quality photo, and you can take your time. You don't need to do it instantly.
Yeah, and this recognition is not sensitive to say one day you actually shave all of your facial hair, and it will still be able to detect. Yeah.
We haven't tried that. I should shave my beard up and see what happens. I don't know. If it did, it's a very simple job to redo a reference image. So if that were to happen and suddenly the system's going, well, I don't know who this person is because he's not got his beard now, it's a matter of 15, 20 seconds to take another image and put that in. And it will then have both those images and compare against either of them.
Cool.
We have a comment here maybe in Twitch chat about the user interface, and just talking about having a friendly user interface, and they actually reference Curio, saying it's got, that was Gus's project from earlier, which was designed, I guess, very much for a younger child. But your interface is not designed for the patient or the elderly person.
No, the interface that was in the presentation is designed for the carers.
Yeah.
And one of the key things there is they want it functional, not pretty, and it just should get in and get out. I mean, care workers are very busy people.
Yes.
And so we've taken out everything that would distract from know which button to hit the button, and you're done.
And I think you were saying as well that the app and the use of the app is almost transparent to the person in the aged care. It's actually trying not to disturb them, and they don't notice what's happening. They don't need to be involved.
Yeah, there are reports for things like if they get a visitor, they might take a photograph of the resident with the visitors who are visiting, because that will then go to the other family members. It's all very secure. It only goes to the family members that the resident has authorized. So occasionally they'll be aware of it, but the idea here is to let many casual workers. I mean, they don't know the people. It's not their fault. They've never seen them before. It would be very nice if they could walk up to them and go, "Hello, John," or "Hello, Joan."
Cool. So it's cool that one of the features is actually to automatically detect face and then share that photo with a family member. Yeah, which is very, very handy.
Yes. Yeah.
And is there any plan, Dave, to actually extend this functionality to actually include video? So sharing a video instead. Yeah.
Possibly. I mean, if we were going to do video, we'd probably reverse it. Instead of blocking out who you don't want to see, we'd say these are the people you do want to see. So we just flip the thing so that we blur out the people you don't select rather than the ones you do select. Because at the moment, as I said, we want very quick interactions for the staff, we haven't included video for doing this. A family member can send a video to a resident, but we haven't reversed it the other way, only because I don't know how willing care staff would be to spend the time making the video. That is one of the things we hope we'd find out in testing. I mean, we'll ask, would you be happy to do this, and see what the response is.
Yep.
Absolutely.
Yeah.
Yeah. So some of the extensions that I guess we're talking about here are the kinds of things that anybody with a child in early childcare, they might be sort of familiar with some of those aspects to it. Not the exact use case that you've got here, but it is kind of interesting, isn't it? That there is this opportunity here to upskill, to uptool this industry.
Yeah, I mean, we've seen things from the Royal Commission about aged care, and I think one of the more people that see what is going on, it's going to improve aged care for everybody. Because you wouldn't put your child into childcare if you weren't getting photographs or at least messages daily of, here they are finger painting or eating their play lunch or whatever. And that's just become normal. And we would love to see that sort of thing happen in aged care as well, that everybody is watching what is going on.
Yeah, even places that look after pets while you're on holiday, they do that kind of thing as well. So let's give the older members of society the respect they deserve as well.
Exactly.
Yeah, and after all, one day we are all age, and we will become the user of your technology. So
yes, that's right. See,
and and you're laying the foundation towards that. Yeah, that's awesome.
Yeah,
and this is slightly maybe off the topic question, but maybe also relevant to you because I noticed that you are heavily involved in app development space, and there is an ML component there as well. So, what's your thought about building and deploying an AI model on the edge using Core ML in iOS? Are there any pros and cons to just using the method that you use here?
I don't know whether we'd need it because although we've got this functionality, I don't think it'll get used. It is not going to be used a lot by any one person at any one time. It's like that, I would assume a worker might use it maybe 10 or 20 times a day, in which case, the little bit of delay sending it up to the Amazon servers is probably not really going to be a problem. So for ease of use, I hadn't considered that because it was very easy to set it up on the we have an EC2 instance and that's it. I mean, it's you saw the very simple PHP code that we use. It was a very simple implementation, which is one of the reasons I was so happy with it. That it took only a couple of days from start to finish to get this up and running.
Yeah, I think that's a very, very interesting. There are so many different ways now that we can deploy machine learning models. So obviously we can make our own, as we've talked about somewhat so far today. Using these AI services from AWS is just so easy. And again, I just implore anybody who hasn't tried them to don't just look at how easy they are, because they still are really powerful, even though they're easy to use, right?
Yeah, and the documentation was very good. I mean, that was the other thing that I'm used to working on iOS and Swift, and the doc's not that good. But
I can attest to that.
The AWS documentation, it was half a day of going through everything, and I was pretty much on top of it.
Yeah, for sure. Yeah, for sure. All right.
Cool.
Good.
So, is there any other question from the floor?
There's certainly interest in some comments going on in the Twitch stream. So yes, it's certainly worth. We'll be hanging around in there as well. But look, Dave, thank you so much.
Thank you.
Yes, you didn't come on with your bio saying that you had some kind of instrument you can play, so I didn't ask you about it. But I see Gus there has got a piano behind him, so maybe we'll have to get him to give us a demo later on. Dave, thanks so much.
Thank you.
And we'll be right back after this.
Thanks.
So I think something that was really interesting from that is that it's not always necessarily about diving into machine learning and trying to build the world's most complex model. It's about using the services that we have available to us to actually apply them to real world business, but also social problems that we can see. And using those AI services there, as Dave was just talking about, is a really cool way of doing it. And I have to note, he may have said this on live as well, but he's just saying how easy it was. It's easy to use this technology, then you apply it to that situation, of course. So I thought that was really cool.
Yeah, cannot agree with you any more than that, Mike. Yeah.
Well, we're up to the last presentation of our day. It has been awesome journey. This last presentation, we have it here because our presenter is actually over in Europe. And so we wanted to give them the opportunity to be awake when they're answering questions. So we've got coming up now, Ola Lekan, who is a machine learning, an AWS machine learning hero. I think they became a hero at the same time as me. I remember seeing them in the list next to me. So machine learning hero, he's an engineer at heart with strong affection solving problems with technology. He has vast experience with building data and machine learning infrastructure on Amazon Web Services. So let's hear from him now.
Everyone, I'm super excited to be part of the AWS Community Day Australia. Interestingly, we're in very, very crazy times at the moment, but I think we'll make this work, and I'm sure we'll have a really, really enjoyable time together today. My name is Olali Kwenleshi, and I'm going to be talking about continuous delivery for AutoML, also AWS Machine Learning Hero. Just to rush right into it, before we get started, I would love to say that I've always wanted to come to Australia. A colleague of mine at my previous workplace flew to Australia, to Sydney for a talk about 2 years ago, 1.5 years ago, and he told me it was about 24-hour flight from Berlin. And I heard that travel restrictions are reducing in Australia and New Zealand at the moment, so hopefully, fingers crossed, at some point in time, I will be able to visit and maybe get whatever we eat in Australia and New Zealand. So I'm going to do a brief introduction of myself. We're going to look through the Amazon AWS machine learning stack. We're going to walk through briefly look through what we already know about the machine learning workloads, and then we look at why AutoML and why we should explore AutoML. We'll then go forth to look at Amazon's AutoML service, Amazon SageMaker Autopilot, and then finally we look at how we build in engineering principles like continuously delivering machine learning models with SageMaker Autopilot with AutoML. So brief introduction, this is me, this is what I look like on a daily basis. I'm a husband, father, and professional, data platform tech lead, maybe on work days, and I do all things data, from data engineering to machine learning to computer vision to artificial, all things data. Also, as I already mentioned, AWS Machine Learning Hero, and then I'm obsessed with customer problems. For me, it's not more going into technology for technology's sake, but also more importantly to solving problems. The finally part is that I'm a lover of sport, and I think I was interested in rugby at some point, only that I don't know how to count the points. So shout out to everyone there. Briefly, let's look at the AWS machine learning stack. AWS comes with a broad spectrum of machine learning services or capabilities depending on what you want to explore. For me personally, I like to always start from the AI services, which are pre-trained models available as APIs where you can pick up and use, and you don't have to think about training your own machine learning model or maintaining all those things. So one of my favorites is Amazon Recognition, which I play with a lot, which has to do with helping with computer vision tasks like identifying objects and images, or doing image classification, object detection, facial analysis, and things that come with that. So you can think of all this at this level of Amazon AI services: Poly, speech and transcribe, comprehend for natural language understanding, translate for language translation, and textract for extracting text in documents or PDFs or images, Kendra, which is really new, which is the search engine that you can plug into any of your services, any of your existing tools, Lex for chatbots. But you can see all these things, and you can see that you don't necessarily have to know anything about machine learning, just pick it up and then start using available as APIs. And then at the next level, you have machine learning services like across starting with SageMaker and all things around SageMaker, like ground truth for data labeling, the machine learning marketplace, and then SageMaker Studio IDE, and the built-in algorithms from SageMaker. Also, you can also see SageMaker notebooks, experiments for tracking how parameters go around within your machine learning experiments, model tuning, which comes out of the box, and SageMaker Autopilot, which is what we're going to talk about, model hosting, model monitoring to see if your model is how predictions are performing in real time, over time, and see if it's drifting and things like that. And the ML frameworks, this is where a lot of people like to talk about, but for me, I'm not so much interested in this, although it's really good. It's the TensorFlow, the MXNet, and AWS comes with deep learning containers that you don't have to maintain your own container on your own, and they're quite optimized for these frameworks. I think in general, mostly when people talk about the ML machine learning capabilities available on AWS, I would recommend that users or as engineers or fellow people in the community if you're solving a problem, start from the AI services and then go to the ML services and then start thinking about the ML. If you want to optimize for an ML framework or you're interested in doing something really, really custom in TensorFlow, MX, and PyTorch, you can then go with that. But then thinking about all these capabilities, all these ML capabilities, then we then go further to say, if I have a machine learning problem, let's say I want to be able to predict, classify, for my son, I want to help him to differentiate between a cat and a dog or different animals. I want to know the faces of what I need to do. First, I need to define the business problem, which is, in this case, I want to help my son identify or differentiate between a cat and a dog. And then I frame it into a machine learning problem. So if there's a cat, there's a dog, there are two classes. So that's more of like a classification problem. And then I start thinking about how to collect data and how to integrate the data set. Then the next step is figuring out how to prepare the data, if I need to rescale the images or if I need to augment the images so that even if I have quite a handful of images, let's say 100, I want to change the background, resize, put in different shapes so that it can the size can grow. And then maybe if I have some visual exploration and analytics to do, and then visualize it. Feature engineering starts understanding, converting features, extracting tensors and things like that, and then putting it into a model training process. I will evaluate my model depending on the accuracy metric or what I'm evaluating, optimizing for. Then if it meets my business goal, so let's say my business goal is that I want to be able to, on my test data set, I want to be able to classify 90% of images or images across both classes, say cats and dogs, accurately. If it doesn't meet it, I go back and collect more data or do some more data augmentation and things like that. And then if it meets it, then I go ahead to start making predictions. Maybe put an endpoint or deploy it to a mobile app for my son to play with. But you can see that if we look at this process, it's quite tedious, considering the fact that not sure people want to spend time on doing a lot of data preparation, visualization. I never understood visualization. In one of my roles in one of my previous jobs, I always had this back and forth with my manager back then that he prefers to use Bokeh, this Python library that you can use to create visualizations in Jupyter, and really nice, it gives some interactive feel. But because I like simplicity and I never really wanted to do anything complex, I just went with Matplotlib. But so you can see that I remember back then having so many back and forth. You can see that these steps, these phases in machine learning in themselves are quite tedious and can be cumbersome, and it can be throw-offs for people that don't want to get into it if you're new into it. As an engineer, I don't want to spend my time doing this. So why AutoML? From a business standpoint, according to Gartner's Magic Quadrant for cloud AI developer services, Gartner predicts that by 2023, 40% of development teams, think about this, 40% of development teams, this is not in one location or another, they're talking about global development teams, will be using automated machine learning services to build models that add AI capabilities to their applications, up from 2% in 2019. This is in a space of, let's say, about 5 years or 4 years, thereabout. we will see 38% jump. This is like an exponential growth. This is an exponential adoption in AutoML, or in adding AI capabilities, not necessarily AutoML, but adding AI capabilities through AutoML into applications by engineers or development teams. This is a great pointer that if 40%, it's in another 4 years, and then it's in 2020 already, why not let's get started as quickly as possible? And this is one of the things I fell in love when I was at reInvent last year. And I read the ML mission at AWS is to put machine learning in the hands of every developer. What this means is that if you think about the ML capabilities from AWS, the AI services, the ML services, and the deep learning frameworks and things like that, whichever spectrum along whichever part favors you along the spectrum, you can decide to pick it up. So, since AWS is already has the mission to put machine learning in the hands of every developer, how do developers actually think? As far as I know, I've always been an engineer at some point, and I still do a lot of engineering. I don't want to spend a lot of time data visualization. I don't want to spend a lot of time doing feature engineering, model training, model evaluation, and things like that. All I want to do is understand the business problem, frame it into a machine learning problem, collect data from my multiple sources, and then feed it into some ML process, and then evaluate if it meets the desired goal, which brings us to the automated way. So in this way, we blank out feature engineering, data collection, data visualization, model training, model tuning, and evaluation, and things like that, and we simplify the entire process. So we go from business problem, machine learning, framing it into a machine learning problem, data collection, data preparation. The AutoML takes care of the whole entire process, and then we evaluate our business goal. Does it meet our business metric? Does it meet our hypothesis? Our hypothesis validated or not? And then if they are validated, we go into deploying an endpoint or making predictions and serving customers with machine learning. Enter Amazon SageMaker Autopilot. In this, so what is SageMaker Autopilot? SageMaker Autopilot automatically trains and tunes the best machine learning models for classification or regression based on your data, while allowing you to maintain full control and visibility. So what I've seen so far with regards to when I talk to colleagues, maybe external people around, is that AutoML is a black box, or machine learning itself is a black box, and then you're automating it, which makes it more of a black box. But the idea about the beautiful thing about SageMaker Autopilot is that it gives you visibility, so you can already you can see what's going on there. So you have your raw data in S3. You specify a target column, and then you give it to SageMaker Autopilot. It does automatic model creation, chooses the right algorithm, ranks based on your accuracy metric that you've selected, and picks up the right model for you, and then tunes for you. And for every model that it creates, it writes a Jupyter notebook. It creates a Jupyter notebook saved in S3 for you. And then you have a model leaderboard, so you can pick any model you want. It gives you the top 10, I think top 20 by default, but you can specify the number you want. And if it meets your choice, if you look at it, this is quite similar to the evaluation of the business metric and the phases of machine learning that we have. If it meets your goal, deploy it. And if you have to do some machine learning explainability, or you have to explain a couple of things, you can go ahead, look at the notebooks, download them, tweak, make a few changes, and then you're good to go. Another thing that I've seen so far is that about 70%, between 70 or 80% of AutoML projects don't go beyond their Jupyter notebooks or their workstations. So how do we get this to go beyond our workstation? SageMaker already enables us to do that by one liner to deploy a machine learning model. But how can we do this in a repeatable way, so that once we have new data, we can train automatically, we can trigger our training jobs or model training jobs, deploy new models into production, and serve our customers automatically. So now we're looking at merging SageMaker Autopilot, the automated machine learning way, with continuous delivery. So This was a project I was working on for a time being, and it's been quite useful for people that used it. So everything is managed by AWS Step Functions, but it starts with a developer, an engineer in mind, pushing some code or doing something into a GitHub repository, and then from that, the AWS environment takes it up. So it starts from the AWS code build that builds up the necessary Docker containers and build the entire end-to-end process. You can also have a schedule trigger. Let's assume you believe that in your workflow, maybe you have new data on a weekly basis or on a monthly basis, and you want to retrain your model. So once the workflow is triggered, it starts a SageMaker Autopilot training and model evaluation job, and it runs in an automated way. So you don't have to spin off a notebook. All you need to do is specify your data location, specify the target column, and it takes care of that underneath the hood. Once the SageMaker model is finally trained and the model is available, the next step is that it triggers the deployment of a SageMaker endpoint. Once the endpoint is available as well, it triggers the deployment of an AWS Lambda function with an API gateway, a REST endpoint, where you can already start connecting to that and making predictions in real time. So you can think of this as an automated end-to-end process. And with this, you don't have to leave your SageMaker Autopilot projects or evaluations in your notebooks alone. You can then have a repeatable way to deploy autopilot models into production. What this brings is that at the point where this is a fully transparent and automated process, so it's managed by AWS Step Functions. If something fails, you can see it, you can get notifications and see that something failed or something went wrong. You can also go back into one of the capabilities of SageMaker Autopilot is that you can go back to inspect the notebooks. I think about 2 weeks ago or less than 2 weeks ago, there was a new release there was an improvement announced by AWS about SageMaker Autopilot with, I think, 400% increase in speed and about 20% increase in accuracy. So you can see that SageMaker Autopilot is getting better, and AWS is fulfilling its mission, is driving its mission of putting machine learning in the hands of every developer. So the project is available on GitHub. There's a link. You can get this from the slides afterwards. CD for AutoML, Amazon Step Function state machine diagram. This is what it looks like. It starts an AutoML job. SageMaker Autopilot is not yet is not have a native integration with Step Function, so there's a Lambda function taking care of that. Continually checks. If the job fails, it gets the job failed and sends a notification. If the job succeeds, it saves the best model, creates a model endpoint configuration. If it needs to update the model, it updates the model or creates an endpoint, and then deploys a REST API. All this via Step Functions, and you don't have to interfere manually with the process. So what's more is that on my free time, I'm working to bring CD for AutoML, which is what I call it, to Amazon CloudFormation. So you can think of it as part of your deploying as part of your CloudFormation stack. It's quite simple. Declare it as a CloudFormation resource. Specify training data path, the target column, notification email, the workflow name, just for whatever the workflow name, you can give it a name, and the schedule. So if you want your model to be trained every 14 days, every 2 weeks, every 7 days, 30 days, you can specify that, and all this is taken care of underneath the hood for you. What you get back is, as the return value in CloudFormation terms, is a REST API. So you don't have to think about how the REST API will be deployed. All this is coupling AWS services together, Lambda and API gateway. In the deployed account, this is all you see. So you see that you're deploying a resource, simple CloudFormation resource for the CD4 AutoML. In the hosting account, you deploy lots of resources like, let's say, Lambda function, event role, IAM role, and a couple of other resources like that. So you can see that there's isolation, and if you think of this as a team that's providing this kind of service for the entire developers in your company, you're already simplifying their lifestyle, their work for them.
Excellent. And I think for finishing up with all the presentations that we've had, talking now about down at the ML level, talking about going into the console, looking at it from a very practical point of view. And we are, of course, as ever, very grateful to be joined by Ola Lekin, who is online with us, even though it's very early. So hello, thank you for joining us.
Thank you. Thanks a lot.
Come on, what time is it there?
It's 5:36 a.m. But I've been awake since about 2:30, tuned to the talks on Twitch. So yeah.
Absolutely. Thank you very much for being here. And yeah, no, I appreciate you getting up so early in the day. Look, so thank you so much for that presentation. As I said just a second ago, very much appreciate sort of now looking at this sort of machine learning layer. So there is services inside of AWS that allow us to be able to build models and your pipelines and your delivery there at a lower level from just those AI services. Now, what have you got any sort of tips, tricks for anybody who's starting out in their machine learning journey? And obviously you're going to say AWS, and I'll let you say that, but any others?
I think I have tips. I would say like I mentioned previously now, just off the chat talk, my wife also started machine learning recently because with a master's education, and she asked me the same question about 2 or 3 months ago. For the people coming from the academic background, I would say start with a lot of just understanding math and then translating it into code in any way that you think about it possible. For someone like me, even though I have a background in computer science, I've not always been a fan of math, but just because I did math because I just wanted to get through, pick up some documentation and start coding it. Just start coding it in any way that you think about it. For people that are more product inclined and solving problems, I think start by thinking about the customer problems that you want to solve, not necessarily because when I started, I was introduced to TensorFlow in 2015. And I didn't just understand how the API worked back then. Back then it was really low level before it then moved into tf.keras. But then later, I think in general, just start by thinking of the problem you intend to solve. And then walk from the problem. There's this Amazon thingy, like walking backwards. Walk back from the problem you intend to solve and to the tool that might help you solve that problem. So if you have to think about image classification or things like or image detection, just walk back from the problem itself. I think that's the basic principle, not from the framework.
That's good advice, yeah. And so you guys, it's not that hard. So what you're waiting for later? Make sure you start building cool stuff with AI. Yeah.
Yeah.
And the next question is, you're definitely using a lot of AWS AI services, yeah. And I'm actually curious, what do you hope that this AI service in AWS to grow in the future? Which direction actually you're hoping it to grow towards?
Okay, so I would first speak from an industry perspective first, which is broader, and then narrow it down to AWS. So I'm not extensively played with, let's say, Microsoft. I think I've played with Google Cloud extensively, AWS extensively, really extensively as well. And I think that if you look at it from the data perspective, because data is what feeds into machine learning, over 70% of data that we have in the world still resides in some unstructured format that is maybe on somebody's PC or maybe in some Excel spreadsheets. And then look at the businesses that want to leverage machine learning. There are lots of them that still don't have access to it. I think eventually it will converge. The idea is to be able to bridge the gap between existing tools that people use at this moment and bring in the state of the art. So there's opportunities in there for cloud providers, in this case, AWS, to help bridge, which is why you see a lot of promotion of the AWS services, like services like personalized things that help people get started with machine learning without having knowledge about machine learning. And it's bridging the gap between data that's residing in different places and the knowledge that's required for machine learning. And I think that that's the direction AWS is moving towards, putting machine learning in the hands of every engineer or every engineer, then taking a step further into putting the machine learning in the hands of almost everybody. I think you can see yesterday or last night or yesterday, this Google Glue Data Brew, which is data engineering from a click perspective. That might be also coming to machine learning. I would see that also coming to machine learning.
Yeah, that was something that we mentioned right back at the start, because we were just sort of introducing the topic, and Gus and I were just talking right back at the beginning about what we'd like to see from this space and from AWS coming in the future. Obviously, reInvent's right around the corner. We're expected to see a lot of announcements at that point. There's always this run up to reInvent where you're getting it now, lots of little announcements that clearly haven't quite made the cut that they're going to be actually in reInvent. And this was one of those. So who knows what we're going to get at reInvent? Obviously, much more exciting things than even this. But yeah, focusing on that data piece prior to machine learning seems to be fertile ground for that. I'm wondering if we're going to see anything more in that space at reInvent.
I think we will. I would say we will. We have to, because to get everybody to do machine learning and to reap the benefits of machine learning at the industry scale, we need to get not just engineers doing it, not just people that have proficiency in machine learning doing it, but even almost everyone, because data resides in Google Sheets, Excel spreadsheets, files reside in people's computers, and people are looking for easier ways. So in my experience, I was a technical product manager for the AI platform at Scout24 at some point. And then when I started, I think this is a good tip. I talked to lots of my engineering colleagues, because I was a data engineer and moved into product management. People were telling me we need to sort out the issues with data quality and things like that. But just by applying simple statistical techniques to find out the real outcome, it turned out that education, which is training people, was the most important, not building a scalable machine learning infrastructure. So once that education is in place, we will see lots of benefits. And I think AWS is building a lot of things in that regard. If you see the previous speaker, I mentioned the AWS documentation is really, really good. And it took him half a day to get started, which is what I think it's the core. Education is the core of getting into machine learning, not just the frameworks themselves. It's getting people the right knowledge.
And clearly, I'm not going to disagree with that, because that's what I do day in, day out. But yes, absolutely. Look, and I think what's interesting there is actually a bit of a discussion going on in Twitch at the moment. There were just some comments going by about looking at having that maths behind ML and AI algorithms to be able to understand it, and that being crucial. And while I would say, yes, I understand where you're coming from with that. But machine learning is a huge topic, right? There's lots to it. And so if you want to dive down into the maths, then there is fertile ground for you to do that, and you can do that. But you can go everywhere from being a research scientist all the way up to being a developer, hooking into those artificial intelligence services, right?
Yeah. So I think to tie to the question that was asked, which is how do you explain AutoML to a manager? I think SageMaker Autopilot does an extensive job in that, in which it documents all the notebooks or the processes in the notebooks. I think in general, AutoML with SageMaker Autopilot is not a black box. I think there's full transparency in there to answer that. And to dive back to your question is, I think as we progress in the industry, it's because I like to speak from the industry perspective first and dive deeper. It's going to become clear, because what I see so far is that AWS is a really product-centric company, and they try to solve problems from that product perspective and they are doing this a lot for the machine learning space as well. But to start with, for anyone delving into machine learning, is move from the AI services first. Just pick something really simple, and then go into the really meaty stuff that you want to maybe with the SageMaker full experience, the studio, the notebooks, the built-in algorithms, which are super efficient. Yep.
Cool. So thanks for all the detailed answer to the question, Olalekan. And again, thank you for coming and joining us, even though it's very early in the morning.
Yep, thank you.
We look forward to inviting you over to Australia when you can leave and when you can arrive here. I note from the beginning of your presentation that you wanted to do that. And we'll have many culinary delights for you to try, like Vegemite and Tim Tams and all the rest of it when you're here.
Yeah, definitely.
Cool. Thank you.
Thank you so much.
Bye.
All right, guys.
That's a long day, Mike, yeah?
Well, yes, it has been a long day. There's been a lot of content. Look, and I know, like, you and I have been sitting under lights and it's kind of hot and all the rest of it, but it's been a very awesome day. I think it's been a true honor to have been here throughout all of these sessions. And what sessions? Like we've covered we've covered so much. It seems like such a long time ago since Gus, you were showing us your AI childminder. Is there a better way to say it than that?
Child nanny, I mean.
Yes.
Okay. Yeah. Well, I have a few interesting talks that I saw today, like the Daniel Bradby with cricket coach. Even though I don't play cricket, I will learn. I will learn it. I will make sure. Right?
LBW.
Yes.
Do you know what do you know what LBW is now?
I still have no idea what it is. But yeah, that was awesome. And then I also like the David Reedy, because of the reason why he built a tech that's
Absolutely.
like very moving for me, And I hope that we all can actually do things like this. It's not necessarily about technology, but what can you solve with this? Is actually what I want everybody to start being aware of, And so, and of course, I like your Lego as well, Mike.
Thank you.
So,
You obviously had to say that. Look, I want a big shout out to a couple of people as well. Ibsen, who was doing the emotion detection, so the video analysis, the emotion detection, first presentation at any conference. It's super awesome. I definitely a space to watch. Follow on LinkedIn, and I think we can expect great things there. And Praddy as well. Thank you so much. Have also been very active in the chat room throughout today as well. We never got to talk to her about the Deep Racer win that she had with SheBuilds. I know she spoke about it in the presentation, but she's obviously going off to reInvent, not physically, but we'll be submitting a Deep Racer model for reInvent, and wish her all the best of luck with that. Represent Australia, New Zealand. Thank you very much for being here. So look, I'm sure that we've got lots of things to look forward to this year. Still, we've got reInvent coming up. There's going to be stuff with the community. So the ANZ community and the Hero community will be talking a lot about the products and services getting out to reInvent. No doubt you and I are going to be talking about a lot of that machine learning stuff as well.
Definitely. And then thanks to all of your audience finally. And you absorb a lot of knowledge today. And it's now your turn to bring this back and build something very cool and come back to us to be the next speaker in the next event.
Absolutely.
And
we'll be
this is
coming
what
and hunting you
community
down. Yes. Look, and finally, obviously, the big thank you to producer John, who's been in the background this entire time and has been helping us throughout the day. Big thank you as well to Peter Hansen, who's done a lot of the work behind the scenes. He was there on day to day, but he's been here throughout the week, helping sure that everything runs smoothly as well. So big shout out to him.
And Kim from for the AWS.
Absolutely. Yes, thank you, Kim. So we got one more day to go this week for the AWS community days. It's not just a day, it's an entire week. We've got one more day coming. It's the video day. We've got some interesting presentations. I guess would say that because I'm going to be one of the people presenting. So I'll be back tomorrow to do that presentation. Here are the others on screen as well. Maybe we'll leave that up and leave it at that. The day starts at 12:30, so don't turn up at whatever time you PM. Yeah, so don't get up that early in the morning and don't come. Each day is slightly different. The video is going to be different yet again. It's going to be very interesting, very awesome day. So look, thanks so much for being with us here today. Connect with us in any which way you want. LinkedIn obviously works for me, and we'll continue the conversation with you. Thank you.
Cool. Awesome. See you guys next event.
Bye-bye.